these two properties will scale accordingly. So for the padding, we have a reference font size of 50 pixels. For 20 pixels, we would need to change this to 0.4 em. 0.4 times 50 gets us back to 20 pixels. For 40 pixels, this would be 0.8 em. 0.8 times 50 pixels gets us back to 40 pixels. And again, 20 pixels is 0.4 em. So if I refresh, there won't be any changes. But watch what happens as I change the font size now. Let's go to 20 pixels. I'll refresh, and you can see the button is scaling correctly with the font size. The padding and border radius has scaled nicely. So we can put any font size value we want here. Let's go make it huge at 100 pixels. You'll see again, the proportion of the border radius and the padding top and bottom is scaling with the font size. So let's now take a look at some EMS guidance. EMS provide a higher level of precision for styling smaller components, as sizing is based on font size of the element itself. So like we just saw, we can have button padding based on the font size of the button itself. Now EMS do provide a lot of precision, but the truth is, using REMS will make very little visual difference. In our Quill project, we're only going to be using REMS. And I suggest when you start out, you also just use REMS. When you become a bit more advanced with CSS, and you really want precision styling, feel free to use EMS. And just to show you that using REMS is totally fine, let's take a look at this application. I'll open up DevTools, and let's go click around on some different elements. We'll click on this heading, and you'll see its font size is set at 3.7 REMS. If I go to a component like a button, which is a good candidate for using EMS, you'll see again, box model properties like border radius and padding are still set in REMS. So here's an example of a professional working application that's just using REMS everywhere. And as I said, we're going to be doing the same, and I wouldn't worry too much about EMS. So let's finish up by adding to our CSS unit summary card. In this chapter, we looked at REMS. We saw common use cases for REMS include text, margin, and padding. And again, the power of using REMS is that when we get to the responsive design topic and learn about media queries, we can instantly change these values by changing the HTML root element's font size for different screen sizes. And this will automatically adjust the text margin and padding properties. Now, pixels, percentages, and REMS are more commonly used, and we're going to be using these throughout our Quill application. There are also properties which are used for specific cases. EMS is an example of one of these. Applying EMS to margin and padding is a common use case. But again, REMS are totally fine, and will make things a lot simpler as we start out. Alright, so let's go add REMS to the Quill homepage. So we're going to go update anytime we're using pixels for fonts, margin, and padding. So all font sizes will be changed to rem, all paddings will be changed to rem, and all margin will be changed to rem. So all we're going to be doing now is updating a whole bunch of values, so we can use REMS moving forward. So I'm back inside the app.css file of our project. We're going to scroll down, and the first thing I need to do is select the HTML root element. We always want the universal selector to come first, and we're going to pop the HTML root element underneath this. Like we saw earlier on, we're going to set the font size to 62.5%. This is basically the same as 10 pixels, and as we spoke about earlier, this is better practice because if someone updates the font size in their browser, like my mum, to something much larger, we're not overriding that value with, say, a font size of 10 pixels. So that's the first thing we need to do. Now we need to go change a whole bunch of pixel values. I'm also going to be highlighting values we don't want to change. In the container, 1200 pixels, we don't want to touch that. We only want to be applying REMS to things which we do want to scale. The reason we have max width at 1200 pixels is for much larger screens. As soon as we start moving down to smaller screens, we want to use REMS. But for a large screen size, there's no need to apply REMS because it's only being used for one case, and that's to ensure our content doesn't spread too wide on larger screens. Anytime we're using small values of pixels, like letter spacing, there's also no point in using REMS, so we're going to leave this as -2 pixels. All the font sizes, we definitely want to update to REMS. So I'm going to change 62 pixels to 6.2 rem. 48 pixels will now become 4.8 rem. 40 pixels will become 4 rem. 32 pixels, 3.2 rem. 24 pixels, 2.4 rem. Now for our paragraph, we're also going to update this to 2 rem. Our anchor tag, will be 1.6 rem. Our small text also needs to change to 1.2 rem. So we've updated the global styles. Let's now go update our different components. The font size in the button, we want to change to 1.6 rem. The pattern we want to change from 15 pixels and 30 pixels to 1.5 rem and 3 rem. The border radius of 8 pixels, we're just going to leave. As we've seen earlier, border radius is a property we just keep in pixels. It's such a small value that rems has very little significance. For the different states of our button, we can see 2 pixels is being used on the border. And again, we're not going to go change that. It's such a small value. For the highlight, we're going to update the padding here to 0.5 rem and here to 1 rem. Again, border radius we're not going to touch. Now for small images, like our logo, medium and small, we're just going to leave those as fixed widths in pixels. As we saw in the guidance earlier, we continue to use pixels for logos and icons. Let's now go down to the different sections of our page, where we'll be changing a lot of margin properties. We'll change our 200 pixel value here to 20 rems. In the hero section, this will now become 30 rems. 10 pixels will become 1 rem, and 50 pixels becomes 5 rems. In the features section, 300 pixels will become 30 rem. The margin bottom here will now become 8 rem. 20 pixels will change to 2 rem. And again, the max width here, I'm just going to leave it 400 pixels. It's the exact same guidance with our container. When using max width, that's just ensuring an image doesn't go too big for a certain screen size. As soon as we reduce the width of the browser, that disappears anyway, and width 100% takes over. We don't need to apply rem values for max width. Going down to our CTA section, we're going to update 300 pixels to 30 rems. And for our CTA card, we're going to leave the max width at 1000 pixels, but we'll update the padding to 10 rem and over here to 20 rem. The border radius, again, we're just going to use pixels. Scrolling down, we're going to update 30 pixels to 3 rem. And in our footer, we're just going to leave the width of this social media icon at 20 pixels. So let's check this out in the browser. So there's been absolutely no change. All I've done is updated our pixel values to the equivalent rem value. If I open up DevTools, let's click on the heading. You can see its font size is 6.2 rems. If I go to computed and check the font size, it's 62 pixels, which was the original font size we set using pixels, but we've now changed to rems. So all we've done here is updated font sizes, paddings, and margins to rems, so that when we get to the responsive design topic, when we use media queries, all those properties will be updated when we update the font size of the root HTML element for different screen sizes. Now, just to give you a taste of this, currently the root element has a font size of 62.5%, or 10 pixels. If I update this to say 50 pixels, which would effectively be 50% times 16 pixels, or 8 pixels, watch what happens as I refresh the browser. All the font size, margin, and padding has now scaled. Let's change this to a much smaller value, like 20 pixels. Okay, again, you can see all the margin, padding, and font size has all scaled down. Now this obviously looks awful, but I just wanted to demonstrate that by just updating this single value now, the font size of the root element, it automatically updates all the padding, margin, and font size within the design. Okay, let's just change this back to 62.5%. Finally, we'll learn how to size elements relative to the viewport with VW and VH. We'll be discussing what are VW and VH, and we'll look at some VW and VH design guidance. So what are VH and VW? View height, VH, and view width, VW, are units that are a percentage of the browser's visible window. So they're kind of like percentages that we've seen earlier, but VH and VW are specifically a percentage of the browser, whereas percentages was based on some parent element. So let's say we have our browser, which currently has a height of 1800 pixels and a width of 3000 pixels. We could have an element shown in red, and we could define its height as 80 VH, which would equal 1800 pixels, the height of the browser, times by 80%, which would give us a value of 1440 pixels. We could give the element a width of 50 VW, which would be 3000 pixels, the browser width, times by 50%. This would equal 1500 pixels. So once again, we're defining the element's dimensions, its width and height, based on the browser's current width and height. Now, of course, the browser can change in both width and height. As a user, you can always go and change the dimensions of your browser. So let's say we now reduced our browser in both width and height. The browser now has a height of 1000 pixels and a width of 2200 pixels. The element's height was defined as 80 VH, which is now 1000 pixels times by 80%, which would be 800 pixels. For the width, we defined it as 50 VW, which would now be 2200 pixels times by 50%, which equals 1100 pixels. So you can see that as we change the width and height of our browser, the element is changing based on the VH and VW values. So let's play around with this in VS Code. I've got the boilerplate HTML, and I've gone ahead and linked a style sheet, which is currently empty. So all I'm going to do is add a single div. Let's head over to app.css. I'll select the div. Let's give it a width of 60 VW and a height of 40 VH. And just a reminder, VW stands for view width and VH stands for view height. And finally, let's just add some background color of light blue. I'm also just going to use the universal selector to remove all padding and all default margin. So let's check this out in the browser. So currently my browser is the full width and height of my screen. So let's open up DevTools. We'll select the div. I'm just going to scroll this up, and you'll even see as I'm scrolling this up, the height of the div is reducing. You can see in the top right corner, the width and height of my browser. So I'm just going to go land at a nice value like 300 pixels. So right now, my browser is 1280 pixels by 300 pixels. Let's go look at the box model. You'll see that the current width of the element is 768 pixels. We defined our width as 60 view widths. So it's going to be 60% of the width of the browser, which is 768 pixels. We defined a height of 40 view heights, which is 40% of the browser height, or 40% of 300, which would be 120 pixels. I'm going to now change the browser width, and you can see the width of the element is also reducing. So it's always 60% the width of the browser. I can also go to the bottom of my browser and reduce the height there. And you can see as I move around, the element is always scaling based on the view height and view width I defined. So let's now take a look at some VH and VW guidance. VH can be used on hero sections in conjunction with min height, so content is always above the fold. Now, above the fold just means it's the portion of the page you don't need to scroll for. Above the fold comes from the newspaper industry. When newspapers are folded, it's the top section of the newspaper. That is, the most important content you want your readers to see straight away. So what we could do is on our hero section, define a total height of 100 view heights. And what this would do is that ensure that this content is always above the fold, so that no matter the height of the browser, you'll always see this content. And this is one of the few instances we set height on a main section. For sections, we usually never set a height. The height of a section is usually defined by the content height and any padding and margin. It's very rare to actually set the height of an entire section, but this is one example where you might want to do it. So I'm on the Duolingo homepage here, and you can see above the fold we have our navigation, this main hero section, and this banner of different languages you can scroll. Now watch what happens when I reduce the height of the browser. All of the content, including that banner at the bottom, is remaining above the fold. There's no additional scroll that's being added hiding any of this content. Eventually, I do get to a height where this breaks, and you can see now it's going below the fold, and I have to scroll. So view height is being used here to ensure that until a certain height, all the content is remaining above the fold, and that at a certain point, a minimum height is being set. Because if you were to make your browser height really small, you wouldn't want all the content being forced into this small section. So view height is being used in conjunction with min height. Just to contrast this with another homepage, this doesn't have view height defined, so that when I reduce the height, you'll see the content just goes below the fold. So let's look at some more guidance. VW can be useful for creating responsive text when it is a main standalone element and not confined within a container. Looking at this page over here, this text is fully responsive. It's not within a container, and as the browser width reduces, the text width also reduces. Let's check this out in the browser. So I've got the page up at full width, and as I reduce the width of the browser, you'll see the text also reduces in width. So let's finally finish off our CSS units summary card. VH and VW are both used for specific cases, so I'm putting it in the red box on the right. For VH, it can be used for defining a section height, which we saw on the Duolingo homepage, and this is totally design dependent. As I mentioned, it's much more common for your section height to be defined by the height of its content and any padding and margin. But you can use VH on an entire section to get the above the fold effect. For VW, we saw we could use it on text, but in all honesty, this is not very common. So I really wouldn't worry too much about it. I did just want to show you a use case. All right, so let's go add view height units to our Quill project. Like we saw earlier in the guidance, on our Quill project, I want our entire header, which includes the navigation bar and this hero section, to always be above the fold, so that when I scroll up, the content isn't cut like this. Now I'm going to give a bit of a heads up. We are going to go implement the view height units, but at this stage of the course, it isn't going to work because we need to master Flexbox first. But let's go set this up. So I'm back inside our index.html file. And as I mentioned, I want all this content inside the header to always be above the fold. So let's go add a class here called header. In app.css, I'm going to scroll down to the different sections. I'll copy this and make a new section called header, which is essentially our nav bar and hero section combined. I'll grab the class header we just defined, and I'll set its height to 100 VH. So let's check this out in the browser. So if I come and scroll up here, you'll see that the page is still being cut. That's because we've defined some margin bottom on our navigation and margin bottom on our hero. Looking back at the CSS file, you can see on our nav bar, we have margin bottom of 20 rems, and on our hero section, margin bottom of 30 rems. Now, adding a height of 100 VH doesn't override that. That margin is still there. For this to work, we need to learn about Flexbox, which is coming up in a few topics' time. Flexbox is the modern approach for laying out containers and elements on your page. And once we implement Flexbox, the height of 100 VH will work. Now, I do want to show you a problem that has been introduced now that we've added height of 100 VH. If I scroll down, you'll see the content from the section below is coming up here. It's kind of like floating above our hero section. Now, the reason this is happening is because we've now defined the height of our section as 100 VH, which is 100% of the current browser window. So all that this content below sees from its perspective is the current height of the browser. So it thinks just to start over here. And if I scroll up further, the section below now thinks the height of the header above is just this height. So it will now start immediately over there. So to fix this, we need to also go add a minimum height so that the header is able to always maintain a minimum height. And if you remember, I mentioned we would implement this towards the end of the previous topic. So let's go do that now. Back in our app.css file, I'm just going to go add a min height, and we'll set the value to 800 pixels. So this will now ensure that the minimum height of the header is always 800 pixels. So let's refresh. I'm going to reduce the height of the browser. If I scroll down, you'll now see that this content is only starting here, which would be 800 pixels from the top of the browser to the start of this section. So I know I may seem a little bit disappointed that we've learnt all about VH and it's not working just yet, but we need our layout to be more fluid, and to achieve that, we need to implement Flexbox, which we will be doing soon. That's all for CSS units. Well done on nailing these crucial concepts. Let's now move on to a shorter but still important topic, CSS functions. CSS functions are a powerful tool for creating dynamic and maintainable styles in web design. In this topic, we'll explore how to establish CSS variables and perform dynamic calculations which help us create more flexible and efficient CSS. Let's begin by learning how to define reusable values for your styles using CSS variables. We'll be discussing how to set CSS variables and the root pseudo class. So what are CSS variables? CSS variables allow us to store values to make it easier to maintain consistency and more easily make global style changes. CSS variables are also known as custom properties. So let's first look at defining a variable. We do it like this, where the variable is set using double dashes. We then have the variable name, in this case primary, which is for a primary color, and this text can be whatever you want. And then we have our stored value, in this case a hex code. So there's defining a variable, and we also need to know about how to use a variable in our code. It's very simple and it's done like this. We have our property, in this case background color, and then we use this variable function, which is the word var with an opening bracket and closing bracket. And inside the brackets, we put our variable, in this case, primary. So CSS variables are first defined and then used inside the variable function. So let's go and see these variables being used on some popular web applications. I'm on the Notion homepage. I'm going to open up DevTools and I'll select the heading. You'll see over here we have color with the var function with the variable name black800 being used. For another example, I'm going to click the button over here and we can see letter spacing again with the variable function and a variable inside of it. So these are examples of the variable being used with the property. But where are these variables being defined? If I scroll down, all these variables are being defined over here on this root pseudo class. You can see all the different variables and the properties. Over here, we can see a whole bunch of colors being defined, and over here, a bunch of different spacing. So what is this root pseudo class? So CSS variables are set on the root pseudo class. We just saw it looks like this, where in red, we have the root pseudo class. And then inside the root pseudo class, we define our variables. And as we've just seen, we then use our variables with the variable function. So the variable can be used in multiple locations. So what is the root pseudo class? It's a special pseudo class selector that matches the root element in a document's hierarchy. The root HTML element looks like this, where we select the HTML tag. And this is basically the same thing. That is the root pseudo class and the HTML type selector. But it is best practice to use the root pseudo class to define your variables. Now there is a slight technical difference which makes the root pseudo class more versatile, but won't make any practical difference in our project. So we're going to be using the root pseudo class, but you could use the HTML root element. It is just better practice to use the root pseudo class. I know when I first learned this, I was seriously thrown off by this new root pseudo class. Honestly, don't worry about it. Just think of it as the HTML root element, and for the purpose of defining variables, it just has a bit more versatility for more complicated projects. So let's go play around with variables inside VS Code. I've got this new index.html file, and I've linked a style sheet which is currently empty. I'm going to go add an anchor tag. For the href value, I'm just going to point it to Google, and I'm going to put the text back here. I'll give it a class of btn. I'm then going to add a div. I'm going to give it a class of card. And inside the div, I'm going to put an h1 and put the text welcome. In app.css, let's go select the button. I'm going to give it a teal background color with this hex code. I'm going to give it some padding of 20 pixels top and bottom and 40 pixels left and right. I'll give some margin bottom of 50 pixels. We'll change its display property to inline block. For the color, we'll give it this gray value. And for the font size, we'll give it 20 pixels. Let's then select the card. I'm going to give it the same background color as what we defined on the button. I'm going to give it a width of 800 pixels and a height of 400 pixels. Finally, I'll select the H1. Let's give it a font size of 50 pixels. And we'll make it the same gray color as used in our button. Okay, so let's check this out in the browser. So as you can see, we have our button. There's some margin at the bottom of 50 pixels. And we have our teal card with an H1 saying welcome. Now, as you can see, we have some repeated values here. For example, this teal color, as well as the gray color on the button and on the H1. As you can imagine, in a large working web application, some properties are going to be repeated a lot, like color. So let's go and use CSS variables to define them in one place. I'm going to come right to the top. I'm going to select the root element pseudo class, which we discussed earlier, and I'm going to define all my variables inside here. Let's define a primary color. So I'm doing -- primary, and I'm going to store this teal value. Let's define a gray color, -- gray, which will be this value over here. Now we can store any value we want. These are color values, but let's go store some CSS units. I'll create a new variable called text-lg to represent large text, and I'm going to give this a value of 50 pixels. It's what we're using in our H1 over here. Let's go do another pixel value. I'll do -- text sm for small, and this value will be 20 pixels. So here we've defined all our variables. Let's now go use them inside the CSS. I'm going to update every place I have this teal color with the variable function, open brackets, and then I'll put in the variable -- primary. I'm just going to copy this and paste it on the card background color as well. For the color property, let's go use the CSS variable there, which is -- gray. I'll copy this, remove the color of the H1 here, and replace it with the variable. For the font size of 20 pixels, let's go add the variable function and put our text small variable. For the font size over here, let's go remove 50 pixels, put our variable function, and grab the text large variable. So I'm going to refresh, and you'll see there's no changes. But we're now using our variables inside our CSS. And the really magical thing about variables is that the values are defined once. So if I wanted to go update my primary color, instead of updating it twice, or as you can imagine in a much larger project, hundreds of times, I'd just come to the primary variable here and change the value. Let's make it this purple color. I'll refresh, and you'll see now, wherever that variable is being used, the color changes. Now, I mentioned earlier that the root pseudo class is better practice over the HTML root element, but just to show you it does work, for a simple use case like this, if I save and refresh, you'll see there's no changes. However, as I've mentioned, it's just better practice to use the root pseudo class. So let's finish up by starting to build out the next summary card, CSS functions. We looked at CSS variables, where for defining a variable, it looked like this, where we use double dashes, and a variable name which we choose. We then give it a stored value, in this case a color, but we saw you can put any kind of values, like units as well. For using a variable, we did it like this, where we have our CSS property, like background color, and then we use the variable function and put inside the brackets our variable. We also learnt about the root pseudo class, where CSS variables are set on the root pseudo class. The root pseudo class look like this, and it's where we define all our CSS variables. So let's jump into VS Code and add CSS variables to our project. The first thing I'd like to do is highlight some areas where it would be useful to have a variable because the value is being repeated several times. You can see, for example, on our button, we're using our primary blue background color. And on our secondary button, we're using the secondary purple background color. We're also using these colors in our highlights. And inside the CTA section, on our cards, we're also using this primary color. So if we ever wanted to later update our primary color, we'd have to go to all these locations and update it. But with the power of CSS variables, we can just define it once and just update the value on the variable, which would change all these different color values we just looked at. So I'm going to scroll right to the top, and I'm going to essentially work through our style guide at the top here and pick different property values we should convert to variables. The first values I want to put as variables are our different font sizes. So we're going to scroll down, we're going to go add the root pseudo class, and I place this right at the top above all the other selectors, as we want our variables to always load in first. I'll add a comment and put font size, and I'm going to define my font sizes like this, -- text. For the small text, I'm going to go -SM for small and give it the value 12 pixels. The next value was 16 pixels. We're using this as our base unit, so I'm going to put that as base and put 16 pixels. The next value, 20 pixels, we're using for paragraphs. So for this project, I'm just going to put -- text paragraph 20 pixels. I'm then going to put the rest of these as each of our headings. So -- text H5 with the value of 24 pixels. And just to avoid boring you, I'm going to go put the others in now. Okay, so I've added in all our font sizes as variables. Now I'm defining it like this, but it's also common to define your font sizes with notation like this, where SM is small. You could leave this as base. You could put this as MD instead of paragraph, MD standing for medium. This would then be L for large. This would then be XL for extra large. And then you would do 2XL, 3XL, 4XL, etc. That is another notation system, which is quite popular. But just for the sake of this project, I want to keep our font size variable names very specific, just so it's clear exactly what they are. The next values I want to define are our font weights. So we'll pop down here, add a new comment, font weights. I'll do -- font weight normal, which is just 400, and then -- font weight bold, which is 700. The next value is line heights. So I'll add a new comment, line heights. I'll define the variable line height tight, which will be 1.2, and line height normal, which will be 1.5. The next values is letter spacing. So let's go add letter spacing as a comment. I'll add a variable letter spacing tight, which is -2 pixels. I'm not going to define a variable for 0 because we don't actually use it anywhere in our project. So there's no need to define a variable there. Next up is font family. So I'll add a comment, font family. I'll create a new variable, font-family. And I'm just going to grab the value we're using in our project down here. So I'll copy that and paste it there. All right, back to our style guide. So we've looked at these properties. Let's go add our colors now. So scrolling back down, I'll add a comment colors. We'll start with our primary color. I'm just going to copy the comment for easy access. I'll define a variable primary base. I'll copy that value there. Next, I'll define primary tint, and I'll copy this value here. And for the last primary value, I'll define primary shade and copy this value here. All right, just to avoid boring you, I'm going to go add in all the different variables for all our different colors. All right, so I've gone and added in variables for our different secondary colors, our different tertiary colors, our different gray colors, and white and black. So let's see what else is left in the style guide. We have border radius and our spacing system. Now, you can go and add these as variables. So for example, you could define a variable space 5, space 10, space 15, space 20, etc. For the purpose of this project, it's a bit overkill, and I'd prefer just to work with the actual units inside the project. For things like margin, the value we're going to be using is specific to the design we wish to achieve, so it's not likely you'd ever want to update those variables. So you can define these variables like border radius and space sizing. I'm just not going to. What I will say though, is that we should still use the values defined in our style guide. So we should continue to use these spacing values, and we should continue to use these border radius values. And if we come and add any more border radius values later, we need to add them into the style guide. So we still have one place where we know all our values. All right, so let's go ahead and use these values in our project. So we're going to scroll from the top of our document to the bottom and just update any values that now need a variable. The first one over here is font family. We define the variable -- font family, and you can see VS Code is able to pick it up. We also define the font weight. So I'm going to grab the variable -- font weight normal. For the line height of 1.5, we define this as line height normal. So let's get the variable -- line height normal. And this gray color is our gray base color. So let's go grab a variable -- gray base. Scrolling down, we can update the font weight of all our headings. So grabbing the variable, this was font weight bold. The line height, we defined it as line weight tight. So we'll grab the variable -- line height tight. For letter spacing, we defined this as letter spacing tight. So variable -- letter spacing tight. And the color for our headings was the gray shade. So variable -- gray shade. All right, I just realized I've just misspelled this. So let me just go update that. So this should be shade. And just making sure to update this here, shade. Now for our headings, we're actually working in rems. So I don't want the variables to be in pixels. So let me just go update those to 1.2 rem, 1.6 rem. And just to avoid boring you, I'm going to do the rest. Okay, so these are updated from pixels to rems. Let's go use them now. So for the font size, I'm going to use the variable text h1. Over here, it's the variable text h2. And just to avoid boring you, I'm going to update the remaining headings and paragraph. Okay, so I've updated all our headings to now use variables. For the anchor tag, I also need to update this, the variable text base. Scrolling down, I also need to update the font size of our small text. This was the variable text small. The font size on our button, we need to update to text base. The padding and border radius we're going to leave. The colors we're now going to come and update. For the background color, we're using primary base, which is the same over here. For the color of the text, we can also update this to white. For the hover and active states, I'm going to update the white there. This blue is the primary shade. So variable, primary shade. And it's the same value being used in the border here. So let's update that to primary shade. For the outline button, this is our base primary color. So I'll update that. And I'll update the border color. We'll change this white to our variable. That's our primary blue color. So let's copy this variable here, add it there, and add it here. Let's also update the white. For the hover and active pseudo class, we're using the shade. So I'll cut this and paste in the variable, and cut this and paste in the variable, as well as update the white. For the secondary button, let's just straight away update the white over here and over here. This is our secondary base. So let's remove this, grab the variable, secondary base. I'll copy that and update this value here. On the hover and active pseudo class, this color value is our secondary shade. So let's remove that, grab variable, secondary shade. We'll copy that and update the value here. Scrolling down to our highlight, the color white will update with the variable. Padding and border rays we leave. And these are just the different base colors for primary, secondary, and tertiary. So let's remove that, grab our primary base, remove this, add our secondary base, and remove this, and add our tertiary base. Scrolling down, so that covers us for all the components. Let's scroll down to the different sections. Now for most of the sections, there's not going to be that many variables to update, because a lot of this is dealing with box model properties, like widths, heights, padding, and margin, and we haven't defined any variables for those. So let's go and see what we need to update. So scrolling down, there's nothing here. It's all margins and widths. Scrolling down. Okay, so the only value we need to update is on the CTA card, the background color. So let's go remove this and grab our primary base color. All right, so I know that was a little bit boring, but our project is now in a much better state, where we're using variables which are defined once in our project. So let's check this out in the browser. Okay, so as you may expect, there's actually been no changes. And that's because all we've done is update the values that were used in the CSS to variables. But check this out now. If I go to our primary base, let's go change this to a totally different color, like this green. Let's update our secondary base color to also something totally different, like this pink. And let's update our tertiary base to this turquoisey color. So I'll save and refresh. And you can see now, with just a few updates, our entire color palette has changed. Now this obviously looks horrible, but I just wanted to show you the power of using variables. All right, let me just change those back. Next up, we'll explore how to perform dynamic computations directly in your styles with CSS calculations. We'll be discussing how to perform calculations and calculations in variables. So what are CSS calculations? We can perform dynamic calculations when setting values. And it looks like this. We use a calc function, which has similar syntax to the variable function we saw earlier, but instead of var, it's calc for calc. And inside the parentheses, we can perform calculations. In this case, we're using mixed units. We're dividing 100% by 3 and minusing 50 pixels. So let's play around with this inside VS Code. So as always, I've got an index.html file with the boilerplate, and I've linked a style sheet which is currently empty. I'm going to go add an image tag, and I've just grabbed this image of the city of Sydney for the source attribute. For the alt text, I'll just put Sydney. So let's check this out in the browser. So as expected, we just have an image of Sydney Harbour. And as you can see, it's absolutely massive because its width and height is just the size of the source file of the image. Let's head over to app.css. I'm going to select the image, and I'm just going to add a width of 100%. I'll refresh, and because this is a standalone image, the parent container is the body, and setting width 100% causes the image to fit nicely inside the body and adjust depending on the width of the browser. I'm going to head back to index.html. I'm going to copy this image tag, and I'm just going to paste it twice. I'll refresh, and now we have 3 images of Sydney Harbour. Now, what I'd like to do is have these images next to each other. So what I could do is update this width, use a calculation, add 100% divided by 3, and then just to show you the use of mixed units, I'm also just going to subtract 50 pixels of the width of each image. So let's refresh, and now you can see the width of the image is 100% divided 3, which essentially splits the current width of the browser divided by 3, and then we're subtracting 50 pixels. Now, just as a note, this is not how you actually want to put images next to each other. We'll be learning a lot more about layouts in the Flexbox and CSS grid topic. All I wanted to show you is how you can use CSS calculations to set properties like width, and how you can use mixed units like percentages and pixels. So let's now move on to variables and calculations. It is common to use variable and calculations in combination. For example, we just saw earlier, we can set variables with the root pseudo class, and you can see here, we have the text h1 variable, which has a value of 50 pixels. Inside our CSS, we could then select the H1 and do something like this, where we use the calculation function. We put in our variable, in this case 50 pixels, and we can then perform a calculation like adding on 10 view widths. In this case, what this is essentially doing is setting an initial font size of 50 pixels, and then depending on the width of the browser, the font size will scale. So let's check this out inside VS Code. I've gone ahead and added an H1 to our markup with the text welcome, and in app.css, I've just added what we just saw. We're selecting the root pseudo class, we're defining a variable text H1 and setting it to 50 pixels. We're then selecting the H1, giving it a font size, and for the font size, we're using a calculation where we use the variable text H1, which is 50 pixels, and then we add on 10 view widths. So let's check this out in the browser. So you can see the text is pretty big, but as I reduce the width of the browser, you can see it's reducing, and that's because a calculation is being performed. 10VW is effectively reducing as I reduce the width of the browser. And if we open up DevTools, if I go to the Computed tab, I'll select the H1. You can see font size is currently 434 pixels. And as I reduce the width of the browser, you can see the font size is dynamically changing. So let's finish off our summary card, CSS functions. We looked at CSS calculations. A CSS calculation is a function that looks like this, where we use the word calc and parentheses to give us the calc function. We also saw we could use mixed units, like percentages and pixels. All right, so let's go and use CSS calculations inside our Quill project. So let's first discuss what we're going to be doing. I'm going to scroll down to our header section. Earlier on in the course, in the CSS units topic, we set our header, which includes the navbar and hero section. Looking at that in the HTML, you can see our header includes the nav and the hero section. We set that to a height of 100 view heights to ensure that content always remained above the fold. Now, I mentioned at that point, we're not really going to see the effect of this until we get up to the Flexbox topic. But what I'd like to do now is use CSS calculations to improve how we've set this up so we can start to see the effect of using 100 view heights. What I'm going to do is go up to our variables. I'm going to add a new comment. I'm going to paste in miscellaneous. I'm terrible at spelling this word, so before this video, I had it in my clipboard to make sure to spell correctly. Under here, we can go add miscellaneous or other kinds of variables. I'm going to define a variable called nav height, and I'm going to set this value now at 300 pixels. Now this value, we are going to come and update later. It's going to be too big for now, and only when we get to the Flexbox topic will our navigation items, like the logo and anchor tags, be in a better layout. Now the reason we want to define a navigation height is because it's a value that will be used throughout the application, across many different pages. So defining a navigation height as a variable is a good idea. So let's now scroll down to our header section. What I'm going to do for now is just comment this out. We are soon going to remove it and do a better implementation of this. I do just want to keep these values here for now. Inside our navbar, I'm now going to go give this the height property, and I'm going to grab the variable nav height. So essentially, we're fixing our navigation height at 300 pixels, which is the value defined on our nav height variable. In our hero section, I'm now going to go set a height. I'm going to use our calculation function. I'm going to initially set this at 100 view heights. But if you think about it, because we've defined a fixed height on our navigation bar, we now need to deduct that from the height of our hero section. That way, both the navigation bar and the hero section will always be above the fold. So I'm going to go minus, grab our variable, and grab the nav height. So what I've effectively done is from the header over here, I've split this height into two. In the nav bar, I'm setting the height using the nav height variable, and in the hero section, I'm setting the height to 100 view heights, and then just deducting off the nav height. I also just need to add the min height onto our hero section. So now I'm going to completely remove this, and I'm just going to go remove the class inside the HTML, as we don't need that now. Now, before we check this out in the browser, just so we can really see what's going on here, I'm going to go add a background color of light blue, and on the hero section, I'll add a background color of light coral. I'm going to come and remove these later, but this will just help us see what's going on. So let's check this out in the browser. Okay, there's quite a bit going on here. First of all, you can see our navigation bar now has a height of 300 pixels. Let's confirm that in DevTools. You can see from the CSS box model, the navigation height is 300 pixels. As I mentioned, I've just made it quite a bit bigger for now. We are going to come and change this value later in the Flexbox topic. We can see we have some white gap here, and that's being defined by this margin bottom. For now, I'm just going to remove it, as we don't really need it right now. I'll refresh, and you'll see now our hero section and navigation bar are touching. I'm going to slightly scroll up the height of the browser, and you can see this is not working how we want it to. It should be that when I scroll down, I no longer see hero section. You can see as I scroll down, the hero section goes on for quite a while. Now this is being caused by the minimum height of 800 pixels. It's currently just too big, so I'm going to come and reduce this down to 400 pixels. I'll refresh, and you'll see when I scroll now, it is behaving how we want it to. It's being cut right at the bottom of the browser, and when I scroll, you can see we're now moving below the fold. Just to confirm this works nicely, if I reduce the height of the browser, the hero section still has a minimum height of 400 pixels. So all the content is still within the hero section. Now the next problem we have is that when I scroll down, there's this big white space here. And that's being set by this large margin bottom of 30 rems. I'm just going to update this to 10 rems in order to reduce it. And you'll see this looks a lot better. So let me extend the browser the full height of my screen. I'll refresh. And if I scroll down now, you'll see this is behaving exactly how we want it to. All the content is above the fold, and as soon as I scroll down, we're on to the next section. I'm going to reduce the height of the browser slightly, and you'll see it's the same effect. I'll scroll down, and we move on to the next section. So just to recap what we've done, because I know it seems a bit confusing. We've effectively set a fixed height on our navigation bar, which at the moment I've set quite large, and we are going to change later. And then I'm using a CSS calculation to set the height of the hero section so that it always remains above the fold. We're using 100 view heights, and we're minusing off the navigation height. And this gives us a really nice effect, where the navigation bar and hero section are always above the fold. And just to reiterate, the minimum height ensures that even when the height goes too small, the hero section still has a minimum height, as you can see in the coral color. Now, this is kind of a halfway implementation. Hopefully you can see we're using the view height units and calculations pretty effectively. But I do just want to highlight that the full implementation will be covered in the Flexbox topic. Just to finish off, I'm going to remove these background colors, as they were there just for demonstration purposes. The last thing I want to do is just scroll up to our nav height variable. I'm just going to pop a comment next to it to remind myself to update the value in the Flexbox topic. That's CSS functions complete. Great work for sticking with me so far. Let's now move on to one of my favorite topics in CSS, Flexbox. Flexbox serves as the foundation for crafting the responsive and flexible layouts that define modern web design. It allows us to easily align and space elements, ensuring websites look great and function seamlessly across all screen sizes and devices. Let's begin by exploring the basics of this powerful layout system with an introduction to Flexbox. We'll be discussing what is Flexbox, Flex Container and Flex Items, main and cross axis, and flex direction. So back in the introduction video to the CSS full course, I introduced this slide, where at a very high level, I broke down the three major components of CSS. We're now up to an exciting part in our journey, where we're starting to look at layout, which is all about how we place boxes on our page. And using the power of Flexbox, grid, and position, we can finally achieve beautifully looking pages that are also responsive for different screen sizes. So what is Flexbox? Flexbox is a one-dimensional layout model, making it simple to arrange items in rows or columns and distribute space. Looking at this page over here, in the navigation bar, we have the logo and some nav links. And on the right, we have a login and try for free. This is a typical layout you'll see for a navigation bar. You can see there's space between these grouped elements, and they're arranged in a row, going from left to right. Inside the hero section, you can see these buttons. Again, there's some space between them, and they're also in a row. Looking now at the hero section, we have a heading, some paragraph text, the grouped buttons, and some images. There's space between each of these, and this is arranged in a column. Now we've seen previously, we can kind of achieve this layout already using things like margin and applying text align to the container so that all block and inline elements center. But Flexbox is a much more modern approach that is far more versatile and far more powerful. So let's check out this page in the browser. All right, so I'm going to open up DevTools, and let's start by clicking on the navigation bar. When I click on this div element, the navigation bar, the word flex appears on the right here. This is signifying to us that Flexbox is being used to arrange items inside this container. You'll also note that the space between the group content is a hatched purple, which is a new color we haven't seen before. You'll also see surrounding the main container is a dashed purple line, and this is also signifying that this is a Flexbox container. Looking now at the hero section, if I select this div here, you can see once again we have that purple dashed line, but this time the content is being arranged down the page, that is, in a column. And you can also see the word flex inside the HTML markup. So let's start getting comfortable with some Flexbox terminology. We'll be looking at Flex Container and Flex Items. Flexbox has two main components. The first is called the Flex Container. This is the parent element. Inside the Flex Container, we have Flex Items. These green boxes are the Flex Items, which are the children of the Flex Container. So Flex Container is the main parent container, and the different elements inside the Flex Container are known as Flex Items, which are the children. So let's now look at how we activate Flexbox with Display Flex. The display property on a container element will activate Flexbox's layout features on children elements. We've seen the display property already, with properties like block and inline. For Flexbox, we use the display value flex, and very importantly, this is declared on the Flex Container, the parent. Just for reference, values for display can include block, inline block, flex, and grid. Earlier on in the course, we've already looked at great detail at block, inline, and inline block. In this topic, we're looking at flex, and in the next topic, we'll be looking at grid. Now, I want to really highlight the difference between when you have no Flexbox, otherwise known as normal flow, and when you do have Flexbox. Let's look at no Flexbox first. This would be a display property like block, which for block elements is just default. We have a container, which acts as the parent, and for elements in block, like headings and paragraphs, they just stack vertically by default. Very importantly, the display property like block is declared on the elements, and we would describe each of these elements as block elements. Let's now compare this with Flexbox. The display property is flex. This now gives us a container, which is known as a Flex Container. And very importantly, flex is declared on the container. So in normal flow, or when not using Flexbox, the display property is applied on the child element. We've seen this a lot already, where, for example, we would apply inline block onto an anchor tag. Inside our Flex Container, we now have Flex Items. And by default, they're not going to stack like this. They're going to be arranged in a row. So we end up with a row of Flex Items. Now, what I want to try get across is that Flexbox essentially takes full control of the layout. So each of these green boxes could be a block element. Let's just say they're all paragraphs. By default, when there's no Flexbox, the paragraphs will stack one below each other. But with Flexbox, they're arranged in a row, and now Flexbox properties take full control of their alignment and spacing. In the next chapter, I'm going to be doing a much deeper dive into normal flow and Flexbox. And the reason I'm doing this is because when I started out, I found it really confusing entering the world of Flexbox and properly understanding how Flexbox completely takes control of the layout. So let's jump into VS Code and play around with this. Alright, so I've gone ahead and set up an index.html file with the boilerplate code and linked an empty app.css file. Inside the body, I'm going to add a div, and I'm going to give this the class of Flex Container. This will be the parent element. Inside the div, I'm going to come and add 4 more divs. These are now the children, and in Flexbox terminology, these will be the Flex Items. I'm just going to put a number on each side of them, 1, 2, 3, and 4, and I'm going to give them each a class of Flex Item, and in this case, 1. I'll copy this class, change this to 2, change this to 3, and change this to 4. So once again, we have our parent div, which is going to be the Flex Container, and we have 4 Flex Items, 1, 2, 3, and 4. Let's jump into app.css. We'll grab the Flex Container. I'm going to give it a width of 800 pixels and a height of 800 pixels. I'm just going to give this container a background color of light gray. Now, as I mentioned, it's really important to understand that the display property for Flexbox is applied on the container. So let's go add display flex. This line of code now activates Flexbox and will mean that the elements contained inside the flex container now become flex items. Now on the flex container, I'm also just going to put a color of white, which will mean that the font color of our flex items will also be white, as this will be inherited. And I'm also just going to give it a font size of 30 pixels, which once again will be inherited by the flex items. So let's go get flex item 1. I'm going to give it a width of 200 pixels, a height of 100 pixels, and let's give it a background color of blue. We'll grab flex item 2. We'll give it a width of 50 pixels, a height of 300 pixels, and a background color of purple. We'll grab flex item 3. Let's give it a width of 100 pixels, a height of 150 pixels, and a background color of red. And finally, flex item 4. Let's give it a width of 150 pixels, a height of 50 pixels, and a background color of green. Now, before we check this out in the browser, I want to comment out display flex, as I want to show you what normal flow looks like when Flexbox is not activated. So let's check this out in the browser. So as expected, because each of these divs, the blue one, the purple one, the red one, and the green one, are just block elements, they're going to stack vertically like this. But now watch what happens when I turn Flexbox on. I'll uncomment this and refresh. And you'll see straight away that these are now arranged in a row, going from left to right. So the important thing to note is that where our flex items are defined in the HTML is by default how they'll be positioned left to right. So flex item 1 is first, and flex item 4 is last. So from left to right, we're going 1, 2, 3, 4. So you can see how Flexbox totally takes control of the alignment of these elements. And as I mentioned in the next chapter, I'm going to be doing a much deeper dive into this idea. And we can also confirm Flexbox has been activated by opening DevTools. We can see on the main container div the word flex. And you can also see those purple dashed lines appearing. You can see purple dashed lines around the entire gray container. You can see purple dashed lines between each flex item. And you can also see on the right some purple hatched area, which is some unused space on the right. The next really important concept we need to talk about is main and cross axis. The main axis is the primary direction in which flexed items are laid out, and the cross axis determines distribution on the secondary axis. Okay, that was a lot to take in. Let's break it down. We have our flex container and our flex items. Now, as I'm sure you know by now, flex items by default appear in a row from left to right. This is what we call the main axis. It's the primary direction in which flex items are laid out. But there's also another axis called the cross axis. And we can also lay out flex items in relation to this axis. Coming up soon in this topic, we're going to be looking at the properties, justify content, and align items. And these are really important properties which are used for aligning our flex items along the main axis and along the cross axis. So just sit tight with me. We will be seeing properties that help us set alignment of our flex items, both along the main axis and along the cross axis. But just in this introductory chapter, we need to get a good understanding of flex direction. Flex direction controls the orientation of the main axis. And very importantly, it's set on the flex container. There are 4 values this can be. The first is flex direction, row, and row is the default value. It's what we've already seen so far, where our flex items go from left to right in a row. So we have our flex item 1, flex item 2, flex item 3, and flex item 4. They're going from left to right in a row. The next property is flex direction row reverse. And as the name suggests, this essentially flips the main axis. So instead of going from left to right, it's now going from right to left, with the cross axis still going down. So now our flex items would be positioned like this: 1, 2, 3, and 4. The flex items are going from right to left. So row and row reverse are complete opposites of each other. The next value we can have is flex direction column. This now completely changes the orientation of the main axis. Instead of going left to right or right to left, it's now going top to bottom, which means that the cross axis is now going left to right. And our flex items would appear like this: 1, 2, 3, and 4. They're moving from top to bottom. The final value we can have for flex direction is flex direction column reverse. And as you could probably guess, this flips the direction of the main axis to now go from bottom to top, with the cross axis still going left to right. So our flex items would now appear like this: 1, 2, 3, and 4, going from the bottom to the top. Now, when I first learned about flex direction, I was so used to coming from a mathematical background with the X and Y axis, where they don't ever change orientation. The X axis is always horizontal, and the Y axis is always vertical. Flexbox is not like that. The main axis, which I've shown in red, can essentially be horizontal in a row, but it can also be vertical in a column. And as we've seen now, in a row, it can go from left to right or right to left. And in a column, it can go from top to bottom and bottom to top. You'll also notice the orientation of the cross axis doesn't really change. We're much more interested in the orientation of the main axis. So let's go play around with this inside VS Code. So I'm back inside the app.css file we worked on earlier. Inside the flex container, I'm now going to go add the property flex direction, and I'm going to initially set it to row. So let's check this out in the browser. So as you can see, there's been no changes from what we had before, and that's because the default value of flex direction is row. So if I remove this, our flex items are in a row from left to right, 1, 2, 3, and 4. Let me add it back in. Now let's go change row to row reverse, and watch what happens. The main axis is now moving from right to left. You'll also notice that these flex items completely shifted from the left side of the container to the right side. In a few chapters' time, we're going to be talking about the important property justify content, is defining how these items are distributed along the main axis. Let's now change flex direction to column. By doing that, we've shifted the main axis from bottom to top, which means that our flex items are now essentially stacked on top of each other vertically. The final value we saw was column reverse. You can see this results in the main axis now moving from bottom to top, where our flex items now start at the bottom of the container and move up the column. And again, you would have noticed how the flex items have now moved from the top of the container to the bottom of the container. Now, one thing I really would like to highlight, because it can be confusing, is that both the display property for flex and flex direction property are defined on the container. They're not defined on the flex items themselves, but on the container. So let's now take a look at some flex direction guidance. In most cases, flex direction is set to row or column. So let's look at some examples of flex direction row first. And as I've mentioned, you do not explicitly need to set flex direction row, as it is the default value. So looking back at this web page here, the two buttons in the hero section, we could use Flexbox to arrange. The buttons are in a row, so the main axis is moving from left to right. We have our cross axis, we have our flex container, and each of the buttons are a flex item. So it's very common to have your main axis going from left to right, that is flex direction row. And again, you don't explicitly need to set this because that is the default value of Flexbox. Looking now at our navigation bar, again, we have items going from left to right. So our main axis is moving from left to right. We have our cross axis, our flex container containing all the items. We have a group of elements on the left, which is our first flex item. And we have a group of elements on the right, which is our second flex item. Let's now look at a case where we use flex direction column. Earlier on in this chapter, we looked at this web page, and the main hero section is in a column. The content is moving from top to bottom. So our main axis looks like this. The cross axis looks like this. We have our flex container and 4 different flex items, which are arranged in a column, moving from top to bottom. So again, flex direction row, which is the default value, and flex direction column are by far the most common values you are going to use. So let's start building a summary card, an introduction to Flexbox. In this chapter, we looked at flex container and items. We saw that we activate Flexbox by using the display property and setting its value to flex. This then gives us a flex container, which is the parent, and inside it, we have flex items, which are the children. We have a main axis, which by default is in row and moves from left to right. And we have a cross axis, which is the secondary axis. We also looked at flex direction. We saw that there were 4 possible values. Flex direction row, where we have our main axis moving from left to right, and our cross axis moving from top to bottom. Flex direction row places our flex items in a row from left to right. So it would look like this: 1, 2, 3, and 4. We saw flex direction row reverse, where our main axis now moves from right to left. The cross axis still from top to bottom. So our flex items are arranged like this: 1, 2, 3, and 4. We then saw flex direction column, where the main axis now moves from top to bottom. The cross axis left to right. Because our main axis now moves top to bottom, our flex items are arranged like this: 1, 2, 3, and 4. The final value we saw was flex direction column reverse, where the main axis now moves from bottom to top, and the cross axis still left to right. This then arranges our flex items like this: 1, 2, 3, and 4. Now, as I mentioned, this can seem very overwhelming with all these different directions flying around. By far, you're going to be using flex direction row, which is just the default value, and flex direction column. So don't worry too much about this. Just understand that the main axis can shift from a horizontal row position to a vertical column position. Now, I know we haven't really spoken about the secondary axis that much, and it may just seem like it's kind of floating there for now, not doing much. In a few chapters' time, we are going to see the importance of the secondary axis, because we can align our flex items both along the main axis as well as the cross axis. So just sit tight, we will see a use for it soon. Next, we'll get a solid understanding of how Flexbox takes full control of the layout of elements by taking a look at normal flow versus Flexbox. We'll be discussing normal flow, Flexbox, and comparing normal flow and Flexbox. Now, this chapter is getting my more difficult stand. When I was starting out, it just took me a bit of time to really understand how Flexbox now fully takes control of child elements inside a Flex container. Now, I'm going to spend a lot of time in this chapter diving deep into the difference between normal flow and Flexbox, so hopefully it will be a bit easier for you starting out. But there is just a little bit of a jump in understanding. So let's start out by looking at the difference between normal flow and Flexbox. When Flexbox is applied to a container, it takes control of the alignment of the children. So looking at normal flow first, spacing and alignment are determined by inherent properties of block and inline elements. So let's say we have a container. Inside the container, we have block elements and an inline element. So this is normal flow with no Flexbox. And all the spacing and alignment properties are inherent in the block and inline element properties. For example, the inline element just takes up the width of the content. Comparing this now to Flexbox. Flexbox overrides default behavior of block and inline elements, with spacing and alignment now controlled by Flexbox properties. So in Flexbox, we have our Flex container. And now for the children, we need to think of these not as block and inline elements, but just as Flex items. So let's take a deep dive into normal flow. Block and inline elements behave differently in normal flow. Let's say we have a div container. We know that the width of the parent container sets the width of the block elements. So let's say we had a block element, which is an H1, and another block element being a paragraph. The block elements stretch the full width of their container and stack vertically. Comparing this to inline elements, where we have an image and 2 anchor tags, inline elements have a width equal to their content and sit next to each other. Now, because inline elements don't take up the full width of the page, there's space between the inline element and the edge of the container, and at the bottom as well. So let's go check this out inside VS Code. All right, I've prepared this index.html file. I have a div with the class container, which is containing these elements: an image, which is a logo from our Quill project, a heading, a paragraph, and 2 anchor tags. Inside app.css, I'm just going to select the container, and I'm going to give it a background color of light gray. So let's check this out in the browser. So I'm going to open up DevTools, and I'm just going to select the different block and inline elements. As we know by now, a block element like an H1 extends the full width of the page and will always start on a new line, like this paragraph over here. For the inline elements, they just occupy the width of their content. In this case, 187 pixels. And for the anchor tags, the length of the text results in the width being 69.75 pixels. And we know inline elements can sit next to each other. Now, with normal flow, when applying box model properties, we've seen in the box model topic, they apply kind of weirdly to inline elements. For example, if I select the anchor tag and try out a height of 50 pixels, and I'll just give it a background color so we can see this, I'll refresh, and you can see the background color has been applied, but the height has not been applied. Just to confirm that, I'll make it a much bigger value, and you'll see height is just not being applied to an inline element. This is not the case for a block element. If I select the H1, give it a height of 100 pixels, and a background color of blue, you'll see that the height is being applied. In the box model, we can see the content is 100 pixels high. With inline elements like anchor tag, properties like padding also apply quite weirdly. I'll remove the height, and I'll add a padding of 50 pixels. I'll refresh, and if you remember from the box model topic, we get this weird behavior where the anchor tag is almost overlapping other content. This doesn't happen with block elements. I'll remove the height on the heading, and I'll give it some padding of 100 pixels. I'll refresh, and you'll see the padding is applied and the content surrounding it is pushed down. Now, we did fix this by changing the display property on the anchor tag to inline block. So if I do this, this will now result in box model properties applying correctly to inline elements. Now, the main idea from this demonstration I just went through is that in normal flow, the positioning and size is heavily determined by whether an element is a block and inline element. And furthermore, box model properties apply a bit weirdly by default to inline elements. The next thing to discuss with normal flow is normal flow and alignment. Applying text align to a block level parent will impact both block and inline children through different mechanisms. I've got the same diagram we just looked at before, and I'm now going to apply text align center to the parent block element, the div. By doing this, two things happen at the same time. The first is that the text inside the block elements will center, and this is being achieved through inheritance. The text align center property is being passed down to the H1 and the paragraph, which effectively applies text align center to each of those elements, which then centers the text. The second thing happening is that the image and anchor tags, the inline elements, have space to move. So applying text align center will center these elements. So the inline elements are being centered because they are a direct child of the div. Now, we've seen in previous topics that applying text align center directly to an inline element won't center it. But when text align center is applied to a parent, like a div, all elements, whether they're block or inline, will center inside the container. So let's go play around with this inside VS Code. All right, so I'm just going to go remove a few things. I'm going to remove all our styles on the anchor tag in H1. I'll refresh, and now I'm going to go apply text align center onto the container. And you'll see that all elements are centered. And just to highlight what I was talking about before, if I remove text align center from the container and put everything back to where it was, and apply text align center to an inline element like our anchor tag, you'll see that nothing happens, whereas it does work for a block like the H1. So once again, applying text align center to a container will center both block and inline elements. So hopefully that was a good recap of normal flow behavior of block and inline elements. Let's now look at how this all changes with Flexbox. Flexbox overrides display behavior of block and inline elements. By applying the property displayFlex to the parent container, it totally overrides block and inline elements. We have our flex container, and the elements are now flex items, overriding the inherent nature of block and inline elements. You can see all elements now start on their own line and by default stretch the full width of the container. So we no longer view our elements now as block and inline when inside a flex container. They're flex items. What were inline elements like images and anchor tags now each appear on their own line and also stretch the full width of the page. Let's play around with this inside VS Code. So I'm back inside our app.css file and I've removed a bunch of styles. I just have the container element with the background color being applied. And just to reinforce normal flow, by opening up DevTools, we can see that our block elements extend the full width of the page, and our inline elements are just the width of their content and do not start on a new line. So let's now convert this to a Flex container. I'll add display flex, and just so we can keep the orientation the same, I'm going to add flex direction column. I'll refresh, and you'll now see when I open up DevTools that all elements extend the full width of the page. The image has been fully stretched. You can also see the anchor tags stretch the full width of the page and now appear on separate lines. They're no longer next to each other. You can see as well, when I select the container, we get those purple lines appearing, separating each element. And these are our flex items. Now, the other interesting thing that happens is because we no longer view these as block and inline elements, applying box model properties to inline elements works. For example, if I select the anchor tag, give it a height of 100 pixels and a background color of red, I'll refresh, and you'll see the height is being applied to the anchor tag. I'll confirm this in DevTools. I'll select the element, and you'll see it has a height of 100 pixels. If you recall when I did this earlier in normal flow, height didn't apply. I'm also going to show you what happens with padding. I'll remove height and add a padding of 50 pixels. I'll refresh, and you'll see padding is also being applied. We're getting 50 pixels of padding all the way around the element. And if you remember in normal flow with inline elements, we had that weird effect where the inline element kind of hovered over some of the other content. So in a nutshell, when our container becomes a flex container, our children now become flex items. Don't think of them as block and inline, because they just don't behave like that anymore. The inline elements appear on a new line, and they stretch the full width of the page. And we can also apply box model properties to them as if they were block elements. I'm just going to go remove this anchor tag, and I'm going to go in on the image and add a width of 100 pixels. So this would be something fairly common to do. We can still add a width to our image to keep it the size we actually want. Opening up DevTools, we can see that our image is now 100 pixels, but you can see it's inside the flex item, which still stretches the full width of the page. So I did just want to show you, in a design like our Quill project, we still have things like fixed width on an image. Now the final thing I want to discuss is comparing alignment in normal flow and Flexbox. In normal flow, we have a setup like this, where applying text align to the parent container centers everything. We discussed earlier, for the block elements, the heading and the paragraph, inheritance results in text centering inside the element. And for the inline elements, in normal flow, text align centered the image and links, as they're just children of the parent container with space to move. Now with Flexbox, we have a setup like this. The top box is the image, where I've applied a fixed width, like we just did a second ago in VS Code. And our headings, paragraphs, and anchor tags all appear on separate lines and stretch the full width of the page. If I were to now apply text align center onto the Flex container, inheritance is still at play. It's being passed down inside each Flex item. So it's kind of like text align is now being applied to the heading, paragraph, and anchor tags. And because we no longer view these as block and inline elements, but now Flex items, text align center will center this text inside the Flex item. Again, we can't view our anchor tags as inline elements anymore. They're just Flex items. However, even with space available, text align no longer moves the image as it doesn't control alignment. This image won't center like it will in normal flow. And that's because Flexbox properties now control alignment, which we're going to be seeing in the next few chapters. Text align will not move a child like it did in normal flow. Let's check this out in VS Code. Alright, so I'm back in the app.css file we were working on earlier. I'm going to come and apply text align center inside our Flex container. I'll refresh and watch what happens. The heading, paragraph, and anchor tags are all centered. Text align center is being inherited by each of these. If I open up DevTools, you can see each Flex item surrounded by the purple dashed lines. You can see there's a lot of space horizontally for these items to move. Because they're all text items, a heading, which is text, a paragraph, which is text, and an anchor tag, which is also text, the text align is being inherited. So it's kind of the same thing as this. If I remove text align center here, I select the heading, paragraph, and the anchor tag, and directly apply text align center to them, you'll see that there's no change. It's all still centered. Now, the big thing to realize is that in normal flow, if I were to apply text-align center to an anchor tag, it wouldn't center it. Whereas in Flexbox, it does, because we no longer view it as an inline element. I'm going to add text-align center back here. I'll refresh. And as I've mentioned, the image is not being centered because text-align center no longer controls alignment like it does in normal flow. We need a specific Flexbox property to center this, which we'll be looking at soon. Just to remind you again of normal flow, I'll comment out the Flexbox properties, I'll refresh, and you'll see the image is now centered. And that's because in normal flow, when applying text-align center onto a container, inline elements are just seen as boxes, that is, children, and they will center because there's space. That works on the inline elements like the images and the anchor tags, whereas in normal flow for block elements, when applying text-align center onto a container, these are centered through inheritance. Alright, so let's finish off the introduction to Flexbox summary card. In this chapter, we looked at normal flow versus Flexbox. We saw that Flexbox overrides block and inline behavior. Inside normal flow, we have a parent container with a block element and an inline element. These elements have inherent behavior, like an inline element taking up the width of its content. And we also saw applying text-align center to a block element container like a div will center both the text inside the block element and move the inline element to the middle. For Flexbox, we now have a flex container and flex items. Flexbox completely overrides block and inline behavior, where now inline elements stretch the full width of the page. And also, we can apply box model properties to what were inline elements without any problem. We also saw that text-align center doesn't always work and won't move something like an image with a fixed width, because text-align center is no longer responsible for alignment inside a flex container. Now, I know this was a lot to take in, and that's why I gave it my more difficult stamp at the start. If you can just walk away from this chapter appreciating that when you apply Flexbox to the container, it will completely override block and inline behavior, and we now also need to use additional properties to align our flex items, then you're doing great. Now it's time to learn about how to control alignment and spacing of elements along the main axis using justified content. We'll be looking at flex container size, the justify content property, justify content values, and justify content and shifting the main axis. So we're now up to an exciting part of our Flexbox journey, where we can start looking at aligning and spacing flex items. Flexbox offers a powerful way to space and align content. Looking at this web page over here, the nav bar, which is a flex container shown in purple, has two flex items in green. Flexbox makes it simple to align and create space between these flex items. Now, before we look at justify content, we need to talk about the flex container size. Understanding a flex container's dimensions is essential for visualizing how flex items will be positioned. When thinking about the size of a flex container, there are two categories. The first is a general block container. We have our browser window and our flex container, which in this case is just a block element like a div, and by default, the block element extends the full width of the container. Let's pop in our main axis and add in some flex items. So along the main axis, there's quite a lot of space. There's space between the last flex item in yellow and the edge of the browser window. Another important note is that the height of the flex container is being determined by the flex items. In this case, the height of the green flex item is setting the height of the entire flex container. This means that there's no space between the largest flex item and the flex container. The other category of flex container is a container with a set height or width. Again, we have our browser, but we now have a flex container that looks like this. In this case, the width is set and the height is also set. Let's pop in our main axis, add in our flex items. We can see the amount of horizontal space here, which you can see is now smaller than the general block container. And in this case, because we've got a height set larger than the height of the biggest flex item, there is now vertical space. Now, the reason I want to get you thinking about where space is inside flex containers is that because in this chapter and the next chapter, we're going to be moving our flex items around. And it's really, really important to understand how much space there is vertically and horizontally to appreciate how our flex items are going to move. Inside VS Code, we had set up this example earlier. We have 4 flex items inside a flex container. This flex container is an example of where width and height has been set. And if I zoom out a bit, you can see that there's space horizontally from the edge of the green flex item to the edge of the flex container, and there's also space vertically from the top edge of the purple flex item here to the edge of the flex container here. Let's comment out those width and height properties. You'll see now that the horizontal space has now expanded and goes all the way up to the edge of the browser window, and that there is no vertical space between the largest flex item and the container. The largest flex item is setting the height of the container. So now that we've got a good understanding of spacing within our flex container, let's finally talk about justify content. Justify content sets how flex items are positioned along the main axis. It looks like this, where justify content is the property and flex start is an example of one of the values. So we have our flex container, and what's really important is that justify content is set on the container. A lot of the next few properties we're going to be looking at are all set on the container and not the flex items themselves. We then have our main axis and our different flex items. So justify content sets how these flex items are positioned along the main axis. In this case, the value is flex start, so they're all at the start of the main axis, that is, on the left. So let's now take a look at all the justify content values. The one we've just seen is justify content flex start. We have our flex container, our main axis, and our flex items. The flex start value has all the flex items starting on the left of the main axis. And this is the default value. It's where our flex items are positioned by default, and what we've already seen in all the examples we've done so far. The next value we'll look at is flex end. And as the name suggests, this now positions all our flex items at the end of the main axis. The next value we'll look at is center. We have our flex container, our main axis, and as you'd guessed, the value center centers all our flex items along the main axis. The next value is space between. We have our flex container, our main axis. The first and last flex items are placed right at the edge of the container, and the remaining flex items are then inserted so that there's equal space between all the flex items. The next value is space around. We have our flex container, our main axis. Now this one works slightly different to space between. For space around, we divide our flex container into equal spacing along the main axis, and then our flex items are centered inside each of these blocks. So what we end up with is that the spacing between the orange, green, blue, and yellow flex items will be double the spacing between the orange flex item and the edge of the flex container, and the yellow flex item and the edge of the flex container. The last value is space evenly. With our flex container, our main axis. In this case, our flex items are all just spaced evenly between each other and the edge of the flex container. So there's equal spacing between all our flex items. This is different to space around, where there isn't equal spacing between all the flex items and the edge of the container. So these are all the 6 possible values for justify content. And just to hammer the point home, justify content is all about spacing our flex items along the main axis. Now I know this can seem a little bit overwhelming, especially the 3 values on the right, space between, space around, and space evenly, as the differences are quite subtle. Honestly, don't worry too much about them. We use some of them a lot more than others. So let's go play around with these inside VS Code. So I'm back inside our app.css file. On the flex container, let's go add justify content, and we'll start with the first value, flex start. I'll refresh, and you'll see nothing changes. And that's just because flex start is the default value. Our flex items are always aligned left by default. Let's change this to flex end. I'll refresh, and you'll see our flex items now shift to the right. The next value we looked at was center. This nicely centers our flex items. We then looked at space between. This places our first and last flex items right at the edge of the flex container, and then inserts the remaining flex items with equal spacing between all the flex items. The next value was space around, and if you remember, this divided the flex container into 4 equal blocks and inserted the flex items in the center of them. And this left us with double the spacing between the flex item and the edge of the container. And we can better see this in DevTools. If I select the Flex container, you can see the spacing of the hatched purple on the far left and far right is half the horizontal spacing between all the other Flex items. The last value we looked at was space evenly, and this simply spaces our Flex items evenly between each other and the edge of the Flex container. Now thinking back to those two categories of Flex container, where we had a general block container, just like this, where it extends the full width of the page, versus a container with set width and height. Let's uncomment this and refresh. Now the reason I want to show you this is that now the Flex container has a set width, so it's not extending the full width of the page. Now because the Flex container now has a set width, which is lower than the width of the browser, the spacing between our items will just be smaller. So let's run through them one more time. So we'll do Flex start, and just to highlight this a bit more, I'm going to come and change the width to 600 pixels. So as expected, our Flex items are on the left. Let's change this to Flex end. You can see our Flex items have moved to the right, but compared to before, it's not like it moved all the way to the right. It has moved right, but because the container has a fixed width, which is smaller than the browser width, the amount it's moved doesn't look like much. Let's go center them, and you can see again, the spacing between all the Flex items and the edge of the container is a lot smaller. We'll do space between, and again, the spacing values are a lot smaller. Space around, and once again, the spacing values are a lot smaller. And finally, space evenly. And again, the spacing values are a lot smaller. So the point of me doing this was really to highlight that the amount of spacing of Flex items along the main axis is heavily influenced on the size of the Flex container. And we've seen it can either be a general block container or a container with fixed width and height. I now want to spend some time discussing spacing on the shifted main axis when we move it from row to column. That is, our main axis is now going vertically instead of horizontally. Let's again look at our two different cases. The general block container will set a flex direction of column. This now results in our main axis going from top to bottom with our Flex items, and the Flex items is what's actually setting the height of the Flex container now. That is, the height of each Flex item adds up to give the height of the Flex container. And this results in no space between the Flex items and the container. So if we come and set a value like justify content center, different values will have no effect on placement of Flex items as there is no space. So because there is no space along the main axis inside the Flex container, setting any value on justify content will have no effect. Let's now compare this with a container with a set height. Again, we'll set Flex direction column. This will result in our main axis going from top to bottom. Our Flex container has a defined fixed height. We'll pop in our Flex items. And now there is space between our Flex items and the edge of the Flex container. So we can set a value like center for justify content. And different values will have an effect on placement of Flex items as there is now space. So let's play around with this inside VS Code. So I'm back inside the file we were working on earlier. Let's go first through the case when the Flex container has no width and height. I'll comment that out. The next thing I need to do is shift the main axis. So we'll go Flex direction column. I'll refresh, and you can see that the height of the container is being determined by the height of each Flex item. If I open up DevTools and inspect, you'll see by looking at the box model, the height of the Flex container is 600 pixels, which is the sum of 100, 300, 150, and 50. So again, for a general block container with no set height, the height is being set by the height of each Flex item. And because there is no space, any justify content value will have no impact. And that's because there's no space along the main axis for our Flex items to shift. So let's go set this to a value like center. You'll see there's no change. We'll change it to space between, and again, no change. Let's now compare this to a container with a set height. I'm going to uncomment these values. I'll zoom out a bit. And because our Flex container now has a fixed height of 800 pixels, and the sum of each of the heights of the Flex items was 600 pixels, there's 200 pixels of space for our Flex items to move. So setting different values on justify content will have an impact. So let's now take a look at some justify content guidance. Justify content is often used to align and space navigation bars. You can see on this web page here The navigation bar will all be inside a flex container. We have our main axis going from left to right. We have a logo on the far left and anchor tags on the far right. These would be our flex items. And we're using justify content to space these flex items along the main axis. Let's check this page out. So I'll open up DevTools. I'll go select the navigation bar, and you can see this is a flex container. If we look at the CSS properties, we can see that justify content is being used with the value space between. Space between is essentially inserting space between the two flex items, pushing the flex items to the left and right. This is a common value you'd be using on a navigation bar. Looking at some more guidance, it can be used to align entire sections. Looking at this page over here, this entire section content would be inside a flex container. We have our main axis in row going from left to right. We have a flex item on the left and a flex item on the right. Now, one thing to note is that Flexbox gives us a simple way to place elements next to each other horizontally. Without Flexbox, this isn't so easy to do. So let's check this out in the browser. So I'm going to open up DevTools, and I'm going to select this flex container. Now, in actual fact, the justify content value is actually not doing anything here. If I turn it off, you'll see there's no change. And that's because we're just using Flexbox as a way to get these elements next to each other. There is no need for a justify content value. This actually can be fairly common, where we're just using Flexbox to position items next to each other, and we don't actually need to specify a justify content value. Here's another example of how Flexbox can be used to align entire sections. All of this content is in a flex container. We have our main axis now in column, going from top to bottom. Inside the flex container, we have a section of content here and a section of content here. And these are our flex items. So let's check this page out. So I'm first going to zoom out quite a lot. I'm going to open up DevTools. I'll select the entire section. You can see flex over here and the flex container with those dashed purple lines. You can see flex direction is in column. And if I turn that off, you'll see it all moves to row. And you'll see justify content is set to center. But if I turn that off, nothing really happens. And once again, that's just because we're using Flexbox as a way to align these items vertically. For this particular layout, there's no need to provide a specific value. Moving on to the next piece of guidance, it's often used for spacing and alignment of simple one-dimensional components. Looking at this web page over here, I'm going to zoom in to the icon and projects. All of this would be inside a flex container. Our main axis is in row running from left to right. We have our icon and text, and these would be our flex items. So again, we're just using Flexbox to easily position items horizontally. So let's check this out in the browser. So I'm going to open up DevTools. I'll grab the container. You can see this is a flex container. As you'd expect, we have display set to flex. Our flex direction is row. This is there even though it's not totally necessary, as row is the default value. And you'll see that justify content is set to flex start. And technically, this is not needed either, because flex start is just the default value. But you can see the power of Flexbox. It easily allows us to position these items next to each other. Now, one question you may have is we do have spacing between the icon and the word projects. So if justify content is not being used there, what is being used? We will be discussing this in a few chapters' time, but there's this property called gap you can see over here, currently set to 16 pixels. And as the name suggests, you can use this to define a specific gap value between your flex items. So if I turn this off, you'll see that projects butts right up against the icon. While we're on this page, I want to show you some other places we're using Flexbox for simple one-dimensional layouts. I'm going to scroll right to the top, and I'm going to click the container of these buttons. You can see this is also Flexbox. Flexbox is being used to nicely position these buttons next to each other. The last example I want to show you is that if I scroll down, we have these different tabs over here. If I select one of these tabs, you can see that Flexbox is also being used here to place the icon next to the text. And like we've seen in other cases, the flex container actually has no space for our flex items to move. This small space in purple here is created by this gap value. If I turn that off, you'll see that we're just using Flexbox to position our elements next to each other. And because there's no space, we can't even use justify content, because we need space inside our flex container for justify content to work. So again, I just wanted to really highlight, oftentimes we don't even need to set a justify content value to position items along our main axis, because in a lot of circumstances, there actually won't be any space. The last example of a simple one-dimensional layout I want to look at is this page over here. We have all these logos inside a Flex container. We have our main axis in row running from left to right, and each of these logos would be a Flex item. In this case, a value for justify content is being used because there is space inside this container to space our items along the main axis. Let's check this out in the browser. So I'll open up DevTools. We'll grab the Flex container. I'll go check out the properties. You'll see we have display Flex as expected, and over here, justify content space between. If I turn this off, you'll see all the icons inside the Flex items butt up against each other. And you can see over here, on the right, the amount of available space inside this Flex container. I'll turn justify content space between back on, and you'll see that using this property nicely aligns our logos along the row with equal space between them all. So let's start building out the next summary card, justify content and align items. In this chapter, we looked at justify content, which positions items along the main axis. We saw there were 6 possible values. Flex start, which is the default value I'm going to put in red. For Flex start, we have our Flex container, our main axis going from left to right, and our Flex items positioned along the main axis at the start of the main axis. That is, in this case, on the left. The next value is Flex end. We have our Flex container, our main axis going from left to right. This means that Flex end is on the right of our main axis. So our Flex items are positioned like this. The next value we saw was center. We have our Flex container, our main axis going from left to right, and our Flex items will be centered along the main axis. The next value was space between. We have our Flex container, our main axis. The Flex items on the far left and far right are pushed right up against the Flex container, and then any remaining Flex items are positioned with equal spacing between each of the Flex items. The next value was space around. We have our Flex container, our main axis. The space is then divided equally, and our Flex items are placed in the center of each of these blocks. And if you recall, this means that the space between each Flex item is double the space between the edge of the Flex container and the Flex items on the left and right. The last value was space evenly. We have our Flex container, our main axis, and this simply just spaces the Flex items evenly with equal spacing between the Flex items and the edges of the container. So we're up to a really exciting part of the Quill project. We're now going to start adding Flexbox onto our homepage. Now we're going to be using Flexbox a lot on the homepage, but just to start off with, I'm only going to be using it in 2 circumstances. And as we move through this topic, I will be adding more instances of Flexbox. The first place I want to use Flexbox is on the navigation bar. We're going to convert our entire nav bar into a Flex container. Our main axis will be in row, running from left to right. Our Quill logo will be a Flex item, and our 2 anchor tags will also be a Flex item. We're then going to use the justify content space between property to create space between the Flex items, just like we saw in some of the previous guidance. So let's jump into VS Code and code this up. So I'm inside index.html of our Quill project. As you can see, we have the nav bar inside the semantic nav element, and this already has a class navbar. We're going to go now convert this nav into a Flex container. So we'll jump into app.css. I'm going to scroll down to the different sections, and you can see our navbar class over here. Now, before I add anything, I want you to note that the current layout by default in normal flow is we have our Quill logo and then our login and register anchor tags, which are one below another because they're inside list items. So let's go add display Flex onto the navbar. I'll refresh and watch what happens. The login and register anchor tags now appear next to the Quill logo. Now you might be wondering, why didn't register appear next to login? Why are these kind of grouped together? If we jump into the index.html file, because we applied a Flex container onto our navbar, the Flex items are direct children of the navbar. That is this anchor tag, which is wrapping our image. So it's effectively just our image, which is over here, and our unordered list, which has the login and register anchor tags. So it's really important to understand that when you add display Flex onto a Flex container, like our nav, the flex items are just the direct children, not grandchildren like these list items. So in our case, the image is one flex item, and the entire unordered list is another flex item. We are later on in this topic going to be talking about nested flexbox, that is, flexbox inside a flexbox. And we're going to be using that to pop our registered anchor tag next to our login. But it's really, really important to understand that flex items are direct children of the flex container. And that is why the login and register are grouped together like this and still appear one below another, because they're inside our unordered list tags, and the unordered list tag is the flex item. Jumping back to app.css, to be explicit, we could put flex direction as row. If I refresh, you'll see no changes. I'm not going to do this because it's not necessary. I'll remove it, but let's now go add justify content and space between. I'll refresh and check that out. With 2 lines of code, we've now beautifully positioned our image on the left and our buttons on the right. All right, the next place I want to use Flexbox is inside our footer. We're going to convert the entire footer into a flex container. In this case, our main axis will now be in column, running from top to bottom. Now, flex items will be the logo, the social media icons, the navigation text, and the small text at the bottom. In the guidance, we spoke about using Flexbox to align and space entire sections, and that's what we're going to be doing inside the footer. And just to note, importantly, there is no space along the main axis. As you'll recall, justify content is about aligning and spacing flex items along the main axis. Our main axis is now in column, and there actually is no space, which means we won't be using justify content. But we are going to be using Flexbox as a new and more versatile way to set up our footer. So let's jump into VS Code and code this up. So our footer currently looks like this. And in actual fact, after we've done the work with Flexbox in this chapter, there's going to be no visual change. But the benefit of using Flexbox is that we're able to unlock some more powerful features, which we'll be seeing later on with values like gap. So even though for now we're going to be doing some work which won't really achieve anything new, using Flexbox is a powerful way to structure layout for entire sections, like this footer over here. Let's take a second to look at the index.html file. We're going to be converting our footer into a flex container. So let's now identify the different flex items. The direct children, which will be the flex items, is this anchor tag, which is wrapping an image, which is the Quill logo. It's this unordered list, which is the group of social media icons. It's this unordered list, which is a mini navigation with the home, login, and register anchor tags. And the final flex item is this paragraph, made with love in London. So again, it's really important to be able to identify your flex items. And just to really hammer the point home, these list items are not flex items of the footer. It's only the direct children which are flex items. So let's jump back into app.css. Let's go add display flex to convert the footer container into a flex container. Let's just refresh to see what happens. So by default, our main axis is running from left to right in a row, and that's why the flex items appear next to each other like this. We want this to appear in a column, so we're going to add flex direction and add the value column. Let's refresh, and you'll see we're actually back to where we started. But now this is a flex container. Now, one thing I do want to highlight, which we spoke about in an earlier chapter, is how we shouldn't really be using text align to space and align items in a flex container, because it doesn't really work. But in this case, it kind of is working. If I comment this out, you'll see that our flex items all appear on the left here. Now, our main axis is running from top to bottom. And as we mentioned earlier, there's no space over there, so justify content won't have any effect. But there is space now along the cross axis. If I open up DevTools, you can see there's a lot of space horizontally. And we're going to be talking in the next chapter about aligning and spacing items along the cross axis. If I turn text align center back on, it does center everything. This seems contradictory to what I spoke about earlier, where I said text align center doesn't really work in flex containers. Just to remind you of that, in the Flexbox versus normal flow chapter, I set up this, where we had our flex container, an image, an h1, paragraph, and anchor tags. In app.css, we have display flex, our flex direction is column, and applying text align center centers the headings, paragraphs, and anchor tags. If I open up DevTools, if I click the anchor tag, you'll see the anchor tag stretches the full width of the page. which is not typical behavior of inline elements. But by converting it to a flex container, this now becomes a flex item, and the idea of inline elements doesn't really apply. This is different to the logo, which has a fixed width of 100 pixels. If I try click away from this, I'm taken straight to the purple dashes of the flex container. This is different to the anchor tag, where you can see by default, the blue box extends the full width of the container. The image doesn't, it's just the width of the image. So trying to apply text align center onto an element with a fixed width like this image simply doesn't work. And that's because text align is no longer taking control of alignment. The only reason the heading and anchor tags are being text align centered is because they're being inherited. So they are centering. So why then is the image centering here? That is completely contradictory to what I spoke about here. Now the reason this is happening is because in our markup, our image is actually inside anchor tags. You can see that over here. The image is wrapped in anchor tags. So the anchor tags are in fact inheriting text align center. Just to really show you this, if I copy this image and paste it over here, I'll refresh, and you'll see this image is behaving exactly like I said here. It's not centering. If I open up DevTools, you'll see this image is inside an anchor tag, and you can see the blue box highlights the space it can move. Whereas this image just has a fixed width, and as soon as I move away, I'm just showing the entire flex container. All right, I'm just going to go remove this image and refresh. Now, this may all seem very confusing, but what I really want to highlight is that text align center isn't really the best way to center items like this. We're going to be seeing in the next chapter a new property which is better used for centering flex items along the cross axis. So for now, I'm actually just going to go remove this. This will then place all our items on the left by default, and in the next chapter, we will be correcting this. I really wouldn't overthink this too much, as I know it can seem confusing, but the main point I want you to walk away with is that inside a flex container, we're learning about flexbox properties like justify content and align items in the next chapter, which is the correct way to properly align and space your flex items. Text align is not the correct way to space items inside flex containers. The last thing I just want to show you is that, as I mentioned, justify content will have no effect because there is no space along our flex container along the main axis. That is going from top to bottom. I'll open up DevTools. I'll grab our flex container. You can see I've added justify content center. I'll refresh. There's no change. I'll add space between, and you'll see once again there is no change. And that's because there is no space inside our flex container along the main axis. But you can see there is a lot of space horizontally, that is along the cross axis. And in the next chapter, we're going to be using that to center our flex items. So as I've just shown, justify content has no effect. So I'm going to go just remove it from our footer. So we've learned about alignment and spacing along the main axis. Now it's time to learn about alignment and spacing along the cross axis with align items. We'll be discussing the align items property, align items values, and align items and shifting the main axis. So what is align items? Align items sets how flex items are positioned along the cross axis. The CSS property looks like this, align-items with a value like stretch. Just like justify content, align items is also set on the flex container, and the value stretch is the default value. And we'll be looking at all the values soon. So let's take a look at our flexbox diagram. We have our flex container, which is the parent. We have our main axis, which in this case has a flex direction of road, which means it's running from left to right. We then have our different flex items, which we know are the children. And we have our cross axis, which runs perpendicular to our main axis. And align items is all about the positioning along the cross axis. So justify content, which we looked at previously, is about spacing and alignment along the main axis. And align items, which we're going to be looking at now, is about positioning and spacing along the cross axis. So let's take a look at the different align items values. Just like I detailed in the justify content chapter, situations where the container has height and situations where the container does not have height, I'm going to be doing the same thing for aligned items. So when no height is set on the container, its height is set by the height of the tallest flex item. So let's take a look at all the values. The first one we have is align item stretch, and this is the default value. It looks like this. We have our flex container, our main axis running from left to right, our cross axis running from top to bottom, And by default, our flex items will stretch. So they'll look like this. Now, just a small note, this occurs when our flex items also don't have a fixed height, so just content. And we'll be looking at this soon inside VS Code. But let's continue running through all the values. The next value is flex start. We have our flex container, our main axis, our cross axis, and our flex items are now at the start of the cross axis. So this is at the top of the cross axis. Now in justify content, flex start would also look like this, but that's because our main axis is running from left to right. So flex start, in terms of justify content, positions the flex items on the left of the main axis. Now align items is positioning along the cross axis. So in this case, flex start means at the top of the cross axis. We then have align items flex end. We have our flex container, our main axis, our cross axis, and our flex items will look like this. That is at the end of the cross axis. You can see it's the complete opposite of align items flex start. The next value is align items center, with our flex container, our main axis, our cross axis, and our flex items will now be centered on the cross axis. So it'll look like this. The final value is align items baseline. So for this one, we have our flex container, our main axis, our cross axis. Now to show you how this works, I'm going to add text inside our flex items. We have a flex item with the letter A inside. I then have a flex item with the letter B, which I've made a lot larger, and flex items with the letter C and D, the same font size as A. Now the way baseline works is that the flex items are aligned along the cross axis so that the text baselines of each item line up based on the largest letter, causing the smaller flex items to adjust upward or downward to match the baseline. Now honestly, this one is a little bit niche and may seem a bit confusing, but we're going to run through all of these now inside VS Code. Alright, so I'm back inside the file we were working on in the previous chapter. I'm just going to come and update these numbers to actual text. I'll write the word banjo, I, hi, and party. I'll refresh, and you can see the text appearing here now. Inside app.css, I'm going to go remove these width and height properties for now, as I want to just work with a regular container. And I'm going to remove flex direction column to get our flex items back in a row. And I'm also just going to remove justify content center for now. So by default, we know that our flex items will be positioned on the left. That is justify content flex start, which is the default value. Now what I want to do to really show you how align items works is for each flex item, I'm going to comment out the width and height, and I'm going to give each item a different font size. I'll give flex item 1 a font size of 90 pixels. For flex item 2, I'll comment out the width and height, and I'll give it a font size of 200 pixels. For flex item 3, comment out the width and height. Let's give it a font size of 150 pixels. And for flex item 4, comment out the width and height, and let's give it a font size of 120 pixels. So I'll refresh, and you'll see some crazy stuff going on. So what we can see is the align items default value, which is stretch, coming into play. Because our flex container has no height, the height of the flex container is being set by the tallest flex item, which in this case is this letter I. Then for the other flex items, they're being stretched the height of the flex container. So if I go add align items, stretch, you'll see nothing changes because this is the default value. Let's now have a look at the next value, flex start. Watch what happens when I refresh. The height of the flex items now only occupy the height they need, and the flex items are now positioned at the start of the cross axis. In this case, we know our row axis runs from left to right, which means that our cross axis is running from top to bottom. So the start of our cross axis is at the top. And once again, the height of the entire container is being set by this letter I, because it is the tallest flex item. If we now change this value to flex end, watch what happens. Our flex items move to the bottom, that is the end of the cross axis, because the cross axis is running from top to bottom. The next value we looked at was center, and these now center our flex items along the cross axis, that is in this case vertically. And the final one we looked at was baseline. Now I want you to keep your eye just under the letter I here, and watch how these other flex items will move downwards as if there was an invisible line running under the letter I. So I hope you saw that those letters move down slightly to be baseline with the letter I. Now, the beauty with Flexbox is that it's very common to use both justify content and align items together. So let's go play around with this. I'm going to go add the justify content property, and I'm going to set it to center. But now I'm just going to comment align items out. So we know justify content will center our flex items along the main axis. That is, in this case, horizontally. Let's now also add align item center. I'll refresh, and you can see our flex items are also now centered along the cross axis. So our items are perfectly centered, both vertically and horizontally. And of course, you can use whatever values you want. Let's change this to flex end. So now our flex items are on the right of our main axis and centered vertically. Let's change align items to flex start. So now our items are aligned on the right along the main axis and at the start of our cross axis, that is at the top over here. So you can see using justify content and align items together allows a lot of flexibility to position your flex items almost anywhere you want inside your flex container. Now, before we move on, I do just want to show you why I removed the fixed heights and widths from each flex item and rather let the content set the dimensions. I'm just going to remove justify content flex end. This will put our flex items back on the left. And I'm also just going to comment out align items flex start. And as we know, the default value of align items is stretch. So the content inside the flex items are stretched. Now I'm going to go change our text back to 1, 2, 3, and 4, and I'll refresh. And then I'm going to go uncomment the width and height, and then comment the font size. So now the width and height of each flex item is going to be set by the width and height I'm defining and not the content inside of it. Just to avoid boring you, I'm going to go do the other two. So now our flex items have a set width and height. I'll refresh and watch what happens. You'll notice that the flex items are no longer stretching. And that's because when you set a specific height on a flex item, it isn't possible for it to stretch. You can think of it as the height is kind of overriding the stretch value. And just to show you, if I were to uncomment this and change the value to stretch, which we know is just the default value, I'll refresh and you'll see there's no changes. But the other align items values still work. For example, if I change this to flex end, you'll see our flex items will move to the bottom. That is the end of our cross axis, which is moving from top to bottom. I can also set this to center, and you'll see that our flex items also center. And of course, just like before, we can also go add justify content and values like flex end. So I just wanted to show you that if our flex items do have a set height, you're not going to see the effect of the default value stretch on align items. And that's because the height is kind of overriding the ability for the flex item to stretch. But as you can see, other values like align item center still work. And this is the reason at the very start of this demonstration, I let the font size set the height of the containers, as I wanted to show you all the values. And if I used a fixed width and height, I wouldn't be able to do this. I know this can be a lot to take in, but honestly, don't overthink it. Most of the time, we're going to be using simple values like align item center, and for values like that, it doesn't matter whether the content is setting the height of the flex item or there is a set height. I did just want to show you this detail so you really do understand what's happening. So we've just been looking at align items when the flex container has no height. So let's now look at when the flex container does have height. When height is set on the container, there is additional space for items to move. So let's look at our 5 different values now. Align items stretch. The flex items are able just to stretch a bit more. Flex start. The flex items are at the start of the container, but compared to the diagram before, there's just a bit more space between the flex items and the bottom of the flex container. It's the same with flex end. There's now just more space vertically between the flex items and the top of the flex container. We have center, and once again, there's now more space vertically and horizontally between the flex items and the flex container, and baseline, where once again, there's just more space vertically. So let's check this out in VS Code to really see the effect. All right, so I'm going to pick up where we left off. On the flex container, I'm going to go give it some height of 800 pixels. And watch what happens to the flex items. Because our align items value is center, and our flex container now has a fixed height larger than the largest flex item's height of 300 pixels, our flex items really do look centered inside this container. Let's play with the other values. We know that stretch isn't going to work because these flex items have a fixed height. Let me quickly remove that and add the font size back in for each flex item. And to avoid boring you, I'm going to go do it for the others. Okay, I've updated all of those. I'll refresh and watch how much more these stretch, because our flex container now has quite a large height on it. Let's change our line items value to flex end. You can see they now go to the bottom of the flex container. That is the end of the cross axis running from top to bottom. And the last value was baseline. I'll refresh. And once again, the numbers 1, 3, and 4 are aligning themselves on the baseline of number 2. Now, when you have a fixed height like this, using justify content and align items can give you some really cool effects. For example, let's go center both. I'll center justify content. This will center our flex items along the main axis. And let's go center align items. And as we know, this will center our flex items along the cross axis, that is from top to bottom. So you can see our flex items are perfectly centered inside this container. So let's now look at align items and shifting the main axis. When no height is set on the container, its height is the sum of flex items' heights, and justify content will have no impact. So I want to look at align items and justify content at the same time when we've shifted the main axis. If we have align items stretch, we have our flex container, our main axis, which is now running from top to bottom because we've shifted the main axis, which means that our cross axis is now moving from left to right. This means that our flex items will look like this. The default value stretch means that our flex items will now stretch the entire length of the cross axis. But because the cross axis is now running from left to right, they're being stretched horizontally. And because the height of the flex items is setting the height of the entire container, there is no space vertically, which means justify content will have no effect. For align items flex start or baseline, it'll look like this. We have our flex container, which once again has no set height. The main axis is running from top to bottom. The cross axis is running from left to right. And our flex items will look like this. They're at the start of our cross axis, that is on the left. And again, there is no vertical space. So any value of justify content simply will not work. Let's now look at align items flex end. We have our flex container, again with no set height. The main axis is running from top to bottom, the cross axis from left to right, and our flex items will be positioned like this, where they're at the end of the cross axis, that is on the right of the container. And once again, because the height of the flex items is setting the height of the entire container, there is no vertical space. So applying any value of justify content will have no effect. The last value is align item center. Once again, we have our flex container, our main axis running from top to bottom, our cross axis running from left to right, and our flex items will be positioned like this. That is, they're centered along the cross axis, and in this case, centered horizontally. And once again, because our flex container's height is being defined by the sum of the flex item's height, there is no vertical space. So justify content will not work. Let's play around with this inside VS Code. So I'm back inside the file we were working on earlier. The first thing I'm going to do is comment out the height. I'll refresh. I'm then just going to remove temporarily our justify content and align items values. And then I'm going to shift the main axis by adding in the property flex direction column. So let's talk about the setup. Our flex container no longer has any fixed height. So the height of the flex container is being defined by the height of the flex items, which is the height of the different numbers. We've also shifted our main axis. So instead of running from left to right, our main axis now runs from top to bottom, which means that our cross axis is running from left to right. The default value of align items is stretch. So our flex items are stretching horizontally now along the cross axis. If I go add align items stretch, you'll see there'll be no change because stretch is the default value. Let's change this to flex start. You'll see now our flex items are on the left. That is the start of the cross axis, which is now running from left to right. For baseline, there's also no change. It's the same as flex start. Let's go change this to flex end. You'll see our flex items now move to the right because that's the end of our cross axis, which is running from left to right. And the final value we'll add is center. And this now centers our flex items along the cross axis, running from left to right. And like we discussed, any justify content value simply won't work because our main axis is running from top and bottom, Justify content spaces and aligns items along the main axis, which in this case is running top to bottom. And because there is no additional space along the main axis, none of these values will work. Let's try flex start, and you'll see there is no change. Okay, I'm just going to remove this one for now. Now, when height is set on the container, there can be additional space, so justify content will have an impact. Looking at our different cases, align item stretch, we have our flex container, which we have set a height on. We've shifted the main axis, so it's running from top to bottom. Our cross axis is running from left to right, and our flex items will look like this. They're being stretched along the cross axis. But because we've defined a height on our flex container, there now is vertical space, so justify content will have an impact. Looking at the values flex start and baseline, our flex container has a defined height. We have our main axis running top to bottom, our cross axis running left to right, and our flex items will appear at the start of the cross axis, that is, on the left over here. And once again, because we've set a height on our flex container, there is now space for justify content to have an effect. The next value, flex end, we have our flex container, which has a height, our main axis top to bottom, our cross axis left to right, and our flex items will be positioned on the right, that is, the end of the cross axis. And because our container has height, there's once again space for justify content to work. Looking at the last value, align item center, we have our flex container, our main axis running from top to bottom, our cross axis running from left to right, and our flex items are centered along the cross axis, that is, in this case, horizontally. And once again, because our flex container has height, there is vertical space for justify content to work. So let's play around with this inside VS Code. So I'm back inside this file, and the first thing I want to do is uncomment out the height. This will give our flex container a height of 800 pixels. I'm also just going to remove the align items property. So I'll refresh, and let's discuss what's happening. We have our main axis running from top to bottom, which is being set by flex direction column. Our flex container now has a fixed height of 800 pixels, which means you can see there's now space between our last flex item and the bottom of the container. And by default, we know that our flex items are going to stretch. And because we've shifted the main axis, our cross axis is now running left to right, so our flex items are stretching from left to right. Let me just explicitly add that, align items stretch. You'll see there are no changes. But now, because we have height on our container, we can add a justify content value like center, and you'll see our flex items will center inside our container. And once again, that's because we now have a height on our flex container, and our main axis runs from top to bottom. So justify content is aligning our items along the main axis. So it's centering our items from top to bottom. Let's change align items to flex start. So you can see our flex items are now positioned on the left, that is the start of the cross axis, which is currently running from left to right, and they're vertically centered along our main axis. Let's change this to flex end, and you'll see that moves our flex items to the right, that is the end of our cross axis. And finally, let's change this to center. So now our flex items are both being centered vertically, which in this case is along our main axis. To justify content center is centering them vertically, and also centered horizontally, which is along our cross axis. So that's being centered by the align item center. So as always, I've gone into a lot of detail between when a container has height, doesn't have height, as well as shifting main axis, as I really want you to understand the details of what's happening. The good news is application in the real world is fairly simple. So let's now take a look at some align items guidance. Align items is commonly used on navigation menus and footers. Looking at this page over here, I'm going to zoom into the navigation bar. The navigation bar is a flex container. The logo on the left is a flex item. The anchor tags in the center are also flex items, and the anchor tag and button on the right are also flex items. We have our main axis running from left to right, our cross axis running from top to bottom. Along the main axis, we would be using justify content with a value like space between to set the horizontal alignment, but we'd also want these items to be vertically aligned, that is, along the cross axis. And in this case, we would want them to be centered. If we didn't do this, the different flex items would just be positioned very weirdly vertically. So I'm on the web page we just looked at. Let's go open up DevTools. We'll select the navigation bar, which you can see is a flex container. We can see we have justify content space between, If I turn that off, you'll see the flex items all just appear next to each other, whereas justify content space between nicely spaces them out. You can see the align items value is set to center. If I turn this off, you can see our logo and anchor tags move to the top, and it just looks very strange, not having all of these items vertically aligned. For the next piece of guidance, align items is often used for positioning items inside a component in a flex row. Looking at this page over here, we have a component like this, which is inside a flex container. Our text is a flex item, and our button is also a flex item. Our main axis is running from left to right. So in a row, our cross axis is running from top to bottom, and you can see that our items are positioned at the bottom of the flex container. That is, we'd be using a value like align items flex end. Another example of this is on this page over here, where we have this icon and text component at the top of the page. This would be inside a flex container. The icon would be a flex item. The text would be a flex item. Our main axis is running from left to right. Our cross axis is running from top to bottom. And we'd be using a value like align items center. So I'm on this page. Let's open up DevTools. You can see this container is a flex container, and align items is set to center. If I remove this, you'll see that they move to the top. So you'll see our flex items are no longer vertically centered, and they're just going back to the default value, which is stretch. Now, it's actually quite hard to see the stretch here because there's no background color. But if I hover over this blue, you can see the blue box is not just the height of the text, it's stretching below. Whereas when I hover over the magnifying glass, because this element is an SVG with a fixed height, which you can see in the box model here as 20 pixels, we're not going to see the effect of stretch there, like we discussed earlier, and it's just going to the start of the cross axis. So let's wrap this chapter up by adding to our summary card, justify content and align items. In this chapter, we looked at align items, which positions flex items along the cross axis. We saw there were 5 values. Align item stretch, which was the default value. We have our container, our main axis running from left to right, which means our cross axis is running from top to bottom. If our flex items are just content, like text, with no fixed height, the default behavior is that they'll stretch along the cross axis. The next value was flex start. We have our flex container, our main axis running left to right, our cross axis running top to bottom, and our flex items are now positioned at the start of the cross axis, that is, at the top. The next value was flex end. We have our container, our main axis left to right, our cross axis top to bottom, which means that our flex items are now positioned at the end of the cross axis, that is, at the bottom. The next value was align items center. We have our flex container, our main axis left to right, our cross axis top to bottom, and our flex items are now positioned in the center of the cross axis. The last value we saw was align items baseline. We have our flex container, our main axis left to right, our cross axis top to bottom. Our flex items had text, which in this case are different sizes, and they'll move up and down on the baseline of the largest piece of text, that is, the letter B. Now, I know this was a lot to take in, and there's so many different circumstances of when your container has height, of when it has no height, when your main axis is shifted, when it's not shifted. There's just a lot going on. The truth is, in practice, it is fairly simple. There's just some common values we're going to be reaching for a lot of the time. As we've just seen in the guidance, align item center is a very common value we want to use to vertically center our flex items. So let's now go and add the align items property onto our Quill homepage. There's 2 parts of the homepage so far we've added Flexbox. The first is on the navigation bar. We have our flex container and our flex items, which is the Quill logo and our 2 buttons. Our main axis is in row, running from left to right, and we have our cross axis running from top to bottom. Just like in the guidance we saw earlier, we want to vertically center our flex items. So let's go add this inside VS Code. So I'm back inside the app.css file. I'm going to scroll down to our nav bar. We currently have display flex and justify content space between. Now, something really important I want to highlight before I go add align items is that our navigation bar has a fixed height, which we're currently defined with the variable nav height. That height is currently set to 300 pixels. And I have a comment here, update the value in the Flexbox topic. Now, I'm not going to update it just yet. We will be changing this value in a few chapters' time when we discuss nested Flexbox. So let me scroll back down. Let's go add a line item center. I'll refresh, and you'll see that our logo and buttons are now vertically centered inside the Flex container. Let's open up DevTools to see that. If I scroll down to the box model, you can see the Flex container, the nav bar, has a height of 300 pixels, which I just showed you earlier. And Align Items is centering the logo and the grouped buttons vertically. Now, as you can see, this does look a bit weird with such a large height and these buttons on top of each other, and we will be sorting this out soon. But we definitely want these Flex items centered vertically like they are here. The next location on our page we're currently using Flexbox is in the footer. We've converted this into a Flex container. We have our Flex items, which is the logo, our social media icons, our anchor text, and our small text at the bottom. These are our Flex items. For the footer, if you recall, we've shifted our main axis. So our main axis is running from top to bottom, which means that our cross axis is running from left to right. At the moment, our Flex items are positioned on the far left, but we want to center them along our cross axis. So we're going to be using the Align Items value center. So let's go add this inside our project. So as I mentioned in our footer down here, our Flex items are all the way on the left. Now, because we've shifted the main axis, we know it's going from top to bottom, and our cross axis is going from left to right. As we've discussed earlier, the default value of Align Items is stretch. Now, we can't really see that going on, but if I go and select temporarily all paragraphs and give it a background color of red, you'll see that this Flex item is stretching along the cross axis. And we discussed earlier that this wouldn't happen for values with fixed height and width, like our logo over here. All right, so let me just remove that. And as discussed, we want to center all these Flex items. So I'm going to go grab Align Items and set the value to center. So this is looking great. Just a small note, our footer links, home, login, and register are still stacked vertically and are aligned left at the moment. Soon we will be correcting this and getting them into a single row. Let's continue to add to our Flexbox knowledge and learn about how to add consistent spacing between Flex items using gap. We'll be discussing Flexbox and the box model and the gap property. So let's start by looking at Flexbox and the box model. Box model properties can still be used in a FlexSpot layout to control spacing. We have our Flex container, our main axis currently in row running from left to right, and our cross axis running from top to bottom. And we have the following Flex items in our Flex container. Margin can be used to space items, and padding can be used in Flex items. So using the box model properties of margin and padding can still be applied to Flex items in a Flex container. Let's check this out in VS Code. So I'm where we left off in the app.css file in the previous chapter. As a reminder, we have these 4 Flex items, we have our Flex container, and our 4 Flex items over here. At the moment, the Flex direction is set to column. I just want to remove that now, so our main axis defaults to row. And I'll just keep Justify Content Center, which as we know, centers our Flex items along the main axis, which currently runs left to right, and Align Item Center, which centers our items along the cross axis, which is currently running from top to bottom. So let's go play around with some different box model properties on our different Flex items. On Flex item 1, let's go add a margin right of 50 pixels. So as expected, this creates 50 pixels space between 1 and 2. Let's go to Flex item 3 and add a margin to all 4 sides of 100 pixels. So you'll see on the left and right, 100 pixel margin. And if we open up DevTools, we can see top and bottom has also had 100 pixels of margin applied to it. Let's go to Flex item 2 and let's add a padding of 40 pixels all the way around. I'll refresh and you'll see padding has been successfully applied. So you can still apply box model properties to your Flex items. Okay, I'm just going to quickly go remove the box model properties I added. Okay, so I'm back to where I'm started. Now, something which is fairly common to do is use Align Items and/or Justify Content to align your Flex items, but then you still want to create even space between each Flex item. So to achieve this, we'd have to do something like add margin right of 50 pixels to our Flex item 1, copy this, add it to Flex item 2, and add it to Flex item 3. So this would create equal space between our flex items that are centered horizontally and vertically. Luckily, Flexbox gives us a much easier way of doing this. And that's where the gap property comes in. Gap sets uniform spacing between flex items on the main axis. The property looks like this: gap and then a unit value. Importantly, gap is set on the flex container. In the demonstration earlier, we had to set margin right on each flex item. It's important to note that gap is set on the flex container, not the flex items. So the way it works is we have our flex container, our main axis running left to right, our cross axis, and applying gap 24 pixels on the container will space our flex items horizontally 24 pixels apart. So instead of applying multiple margin properties on flex items, we can just apply a single property, gap, on the flex container. And we can also do this when the main axis is shifted. So for example, we'll shift our main axis so it's in column. Our cross axis now runs left to right, and our flex items will now have a gap between them of 24 pixels. Because again, gap sets the spacing between flex items on the main axis. So let's play around with this inside VS Code. So I'm back inside the file we were working on just earlier. I'm going to go remove margin right from each flex item. Okay, so we're back to where we started now, with our flex items all butt up next to each other. All we're going to do is get the gap property, add a value of say 50 pixels, and voila, we have equal spacing of 50 pixels between each flex item. And of course, we can change the direction of our main axis. So we'll do flex direction column. So our main axis is now running from top to bottom, and our cross axis is running from left to right. And you can still see gap 50 pixels has been applied between each flex item. And remember, gap is equal spacing of your flex items along the main axis. So let's now take a look at some margin and gap guidance. Margin is used when you want different spacing values between flex items. On this page here, we have these two cards. Let's focus on the card on the left. This is all inside a flex container. Our main axis is in column running from top to bottom. And we have 4 flex items: this icon, the heading, paragraph, and anchor tag. Each of these flex items have different spacing values between them. So we can use margin on the flex items to achieve this desired effect of different spacing values between the flex items. All right, so I'm on the page here. Let's open up DevTools. I've clicked on the card, which is the main flex container. You can see there's no gap property applied. But if I click on each flex item, each of these divs, you'll see this first div has a margin bottom of 32 pixels. Let's turn that off, and you'll see the spacing disappears between the icon and the heading. You'll see this piece of text here has a margin top of 8 pixels, so a different margin value than what we just saw. And finally, this anchor tag has a margin top of 32 pixels. So if I turn that off, you'll see the spacing between the text above and the anchor tag disappears. So you can use margin on each flex item if you want different spacing between your flex items. Now, gap is used when you want uniform spacing values between your flex items. For example, in the footer on this page, each column of the footer links lives inside a flex container, where each anchor tag is a flex item. We have our main axis running from top to bottom in column, and for equal spacing of say 12 pixels between each flex item, we can just use the gap property. Now, in all honesty, because of the power of the gap property, it is a lot more commonly used than using different margin values. Let's check out this application again, and I'm going to show you multiple places gap is used. I'm going to open up DevTools. I'm going to select this hero section. You can see it's a flex container, and you can see over here the gap property of 28 pixels is being applied to achieve equal spacing between all the flex items. Let's go find some more. This card over here is also a flex container. And in this case, there's only 2 flex items. We have this item here and this item here. And you'll see gap is being used at 8 pixels. Now, this is actually very common, to only have 2 flex items and then apply a gap property to space them out. Let's go look for more examples. You can see on this card over here, again, it's a flex container. And again, gap is being used to separate the 3 different flex items. Even on this major section over here, Flexbox is used to nicely align these 2 large flex items next to each other. And to create some extra space, a gap of 32 pixels is being used. And of course, like I showed in the demonstration, if I go and select the footer, you can see we have a gap of 12 pixels being used between each of the anchor tags. So it's common to use gap to create spacing between your flex items. So let's start building out our next summary card. Gap, nested flexbox, and centering. In this chapter, we looked at gap. We saw the property looked like this. Gap is applied on our flex container, and it creates spacing along our main axis. So a gap of 20 pixels applied to our flex items would look like this, where the space between each flex items is 20 pixels. So let's go ahead and add the gap property inside our Quill project. As a reminder, we're currently using Flexbox in two places. The first is on the navigation bar, where we have a flex container. We have our two flex items, the logo in the left, and the grouped anchor tags on the right. Our main axis is in row, running from left to right, and we're using the justify content space between property to space the flex items along the main axis. We have our cross axis, and we're using align item center to space the flex items vertically along the cross axis. Now, gap is used to space items along the main axis, and because these are spaced how we want them to already, that is, the logo on the left and the grouped anchor tags on the right, there's no gap or margin required on this flex container. The second place we're using Flexbox is on our footer down here. Our entire footer is a flex container, and we have 4 different flex items: the logo, our social media icons, our anchor tags, and the small text. In this layout, our main axis is in column, running from top to bottom, with our cross axis running from left to right. Now, this is a great place to use gap. We want equal spacing between each of our flex items along the main axis. So let's go add this to our project. So I'm back inside our app.css file of our Quill project. I've scrolled down to the footer, and all we need to do is add the gap property, and I'm just going to give it a gap of 1 ren, which from the unit section of the course we know is 10 pixels. So I'll refresh the page, and this creates a small gap of 10 pixels between each flex item. And again, just remember, the gap property is applied on the flex container, which is our footer over here. Next up, we'll explore how to create more complex layouts by combining multiple containers with nested flexbox. We'll be discussing what is nested flexbox and nested flexbox guidance. So what is nested flexbox? It is common to have a flexbox layout inside another flexbox layout. So looking at this page over here, this entire hero section is inside a flex container, and the 2 buttons are also inside a flex container. Because this flex container is inside the other flex container, we would call this a nested flex container. It's nested within another flex container. Let's check out this page in DevTools. I'll grab the hero section, and as you can see, this is a flex container. If I expand this div, you'll see that this div down here, which is nested inside this div, is also a flex container. So we have a flex container inside another flex container. So the interesting thing happening here is that for this flex container, each of these are flex items. And this last flex item is also now a flex container. So a flex item within a flex container can also function as a flex container itself, allowing for multi-level flex layouts. So looking at this in diagram form, we have our first flex container, we have our different flex items. We can then make one of our flex items a flex container. And because this flex container is within another flex container, we would call it a nested flex container. And of course, this nested flex container will have its own flex items, shown in blue here, which we could call nested flex items. So let's go play around with this inside VS Code. Alright, we're making great progress so far in this topic. I now want to step up our coding exercises a bit and build this simple layout using nested flexbox, which could appear on an About Us section of a web page. Alright, so I've gone ahead and set up an index.html file with the boilerplate code and linked a style sheet called app.css, which is currently empty. Let's first go add the main blue background container. I'm going to add the div and give it a class of main container. Inside the div, I want to add our 3 different profile cards. So I'm going to do div times 3, and I'm going to give it a class of profile card. And I'll just copy this class onto the other 2 divs. So we're just going to start off nice and slow by getting our profile cards inside our main container. Let's head over to app.css. I'm going to select the main container. I'm going to give it a height of 800 pixels and a background color of light blue. So let's open up the browser and see what we have. Okay, nothing spectacular. We just have our main container with a height of 800 pixels and a light blue background. Let's now go add those 3 profile cards. I'm going to select the profile card. I'm going to give it a width of 300 pixels. I'm going to give it a height of 400 pixels. And just note, we'll later be removing this height and adding in actual content. But for now, because there is no content, we need to go and explicitly define a height so we can see our profile card. And let's give it a background color of white. I'll refresh, and our cards are now just stacked vertically on the left. I'll open up DevTools, and you can see we have our 3 cards running down the left here. So let's now go and align them using Flexbox inside our main container. All I'm going to do is come to the main container, grab the display property, and make this a flex container. I'll refresh, and our cards are now stacked next to each other inside the main container. If I inspect this in DevTools, you can see our 3 cards over here. Now by default, we know that the main axis runs from left to right in row, and the cross axis will run top to bottom. You can also see there's space horizontally along the main axis and space vertically along the cross axis, because we've defined a fixed height on this container. So let's first go and space our profile cards along our main axis. I want even space between this. And we know that the property to use for alignment and spacing along the main axis is justify content. And I'm going to set its value to space evenly. I'll refresh, and you can see our cards are now spaced evenly along the main axis. Next up, I want these cards to be vertically centered inside our container. We know that to space flex items along the cross axis, which is running from top to bottom, we use the property align items. And to vertically center it, I'm going to use the value center. Okay, great. This is starting to take some form. Before we start adding the content into our cards, I just want to slightly improve this by adding a border radius and giving a value of 10 pixels. So our corners are now nicely rounded. All right, I'm going to head back to index.html, and I now want to go add content inside our profile cards. The first piece of content we had was that emoji. I've just grabbed it off the web, and it's an SVG currently sitting in my clipboard. I'm just going to paste here. So that's the profile emoji. The next element I'm going to add is an H2, which is the name of the person. The first person we had was Jane Doe. Next up, I'm going to add a paragraph tag and add their job title, which was software engineer. And then below this, we had those 3 social media icons. For now, I'm just going to add a placeholder paragraph and write the word social media icons, which we're going to come and update a bit later. So I'm now just going to copy this div and delete these 2 others, and paste it once and twice. So we now have 3 cards with the same structure. Just to keep them unique, I'm going to go update this SVG to another one I have sitting in my clipboard. The second person was John Smith. Their job title was product designer. And I'm just going to leave the placeholder social media icons paragraph for now. Now to avoid boring you, I'm just going to go update the content on our 3rd profile card. All right, so our 3 profile cards are now inside our main container. With our first one over here, our second one over here, and our 3rd one over here. So let's check this out in the browser. Okay, great. Our profile cards are looking a lot better with the content in. Let's head over to app.css and now work on the profile card. The first thing you'll see is that the content is actually overflowing the card. And that's because we previously set a fixed height on the card, as we had no content. Let's now remove this, as we do have content, which will give our card height. I'll refresh, and you'll see the height of the profile card is now being set by the sum of the heights of the different elements. So let's now use Flexbox inside each profile card to better space and align the content inside here. So essentially what we're going to be doing is now making our profile card a flex container. Looking back at our HTML, currently our main container is a flex container, which means that each of these divs is a flex item. But now, these flex items are also going to become their own flex containers, where the content inside these divs, that is the SVG, H2, and 2 paragraphs, will now become the flex items. So just to really highlight this main div, wrapping all the content, is a flex container. These 3 divs are each flex items of this main container, but now they're also going to become their own flex container, where the content inside of them will become flex items. we have 3 flex containers, 1, 2, and 3, inside another flex container. So all we're going to do on our profile card is add display flex. I'll refresh. Now, because the default value of flex direction is row, it now moves our flex items inside the card, which is the different pieces of content, into a row along the main axis. We don't want them positioned like this. We want them going vertically. So we need to shift the main axis by grabbing the flex direction property and adding the value column. I'll refresh, and we're kind of back to where we were before. But now our profile card is a flex container, and each of these elements is a flex item. Let's check this in DevTools. You can see this profile card is flex, and you can see those purple dashed lines appearing, signifying that this is a flex container. And once again, the main container over here is also a flex container. So our profile card is a nested flex container because it's a flex container inside another flex container. Let's now go better align and space the content inside the profile card. Now, the spacing we see between the different elements is currently being set by default margin in the browser. If I open this up, you can see in the box model, there's default margin being applied to each of these text elements. So I'm just going to go do our mini CSS reset. I'll use the universal selector to select every element, and I'm going to go remove any default padding and any default margin. Okay, so all margin and padding has been removed from the page. Now, because our main axis inside the profile card is running from top to bottom, and I'd like to achieve equal spacing between each of these elements, I'm going to use the gap property, and I'll set its value to 20 pixels. If you recall from earlier, the gap property sets equal spacing between flex items along the main axis. And once again, in our profile card, the main axis is running from top to bottom. So we get equal vertical spacing between each of our elements. Let's check this out in DevTools. You can see that hatched purple is an equal spacing of 20 pixels. The last thing I want to do is horizontally center each of our elements. Now, once again, our main axis is running from top to bottom, which means our cross axis is running from left to right. And we know for spacing and alignment along the cross axis, we use the align items property. So I'm going to grab align items. I'm going to set its value to center. And this will nicely center all our content. Now, before we handle our social media icons, I want to just go add a bit of padding to our card. As it's looking a bit cramped, let's give it a value of 20 pixels. Okay, that just creates a bit of extra space inside our card. So let's now go tackle the social media icons. I'm back inside the index.html file. I'm now going to go replace this paragraph with a div. And inside the div, I'm going to add 3 SVGs that are currently sitting in my clipboard and I've just grabbed from the web. Okay, so we have our 3 social media icons here, which are contained within a div. Now, these icons are identical for the other cards. So I'm just going to go remove the paragraph here, add in the content there, remove the paragraph here, and add in the content here. All right, so let's check this out in the browser. All right, this is looking pretty good as it is. The SVGs appear nicely next to each other like this because by default, they're inline elements. And inline elements do not start on a new line. Now, what I would like to do, though, is have better control of spacing and alignment of these SVGs by converting this div container into a flex container. So effectively, we're now going to have 3 levels of Flexbox. Our first level is the main container, which contains 3 flex items, the 3 different profile cards, this one here, and this one here. We know that our profile card are also flex containers, where the flex items are the SVG, the H2, the paragraph, and now this div. And we're now going to go convert this flex item, this div, into its own flex container, which means that each of these SVGs will be flex items of this flex container. Now I need to add a class to this div, and I'm going to call it social icons. I'm going to copy this and just add it to our other div containers for the social media icons. In app.css, I'm now going to go select the social icons, and we're going to convert this into a flex container by adding display flex. I'll refresh, and you'll see not much changes. Our SVGs are still positioned horizontally next to each other because by default, our flex items, that is the SVGs, are in row because the main axis runs from left to right by default. But just to show you that this now is a flex container, if I go add flex direction and set this to column, you'll see our social media icons will appear one below each other. Okay, I'm just going to remove this. And the only thing I actually want to do on the social media icons is create equal spacing between them. I'm going to use the gap property, which we know sets equal spacing between flex items along the main axis. And I'm just going to set this value to 10 pixels. All right, before we check out our masterwork and expand the browser full screen, I've realized this emoji isn't correct. I'm going to go just update that in the HTML. All right, great. I've just updated that emoji. So let's go check out our beautiful work. All right, this looks fantastic. We've now built a simple section of a web page, and we've used 3 different levels of Flexbox. Opening up DevTools, we have our main container, which is a Flex container. Each of these profile cards are Flex items of this main container. We then made these profile cards their own Flex containers to space and align the content inside the card. Inside the profile card, it has the Flex items of an SVG, an H2, a paragraph, and a div. And then this Flex item, the div, we also converted to a Flex container, which has 3 SVGs. So in this demonstration, we've nested Flexbox twice. Anyways, I hope this was a bit of fun and is able to also help consolidate a lot of the other properties we've been learning about so far. So let's now take a look at some nested Flexbox guidance. Nested Flexbox is commonly used on navigation menus and footers. Looking at this page over here, I'm going to zoom into the navigation bar. All of the content in the navigation bar is inside a Flex container in purple. We have 2 Flex items. On the left, we have our logo, which is a Flex item, and all the anchor tags on the right are also grouped as a Flex item. We would then use a property like justify content space between to space these 2 Flex items. I'm now going to zoom in on the Flex item on the right. This Flex item would also become a Flex container. So this is now a nested Flex container. And we then have our different Flex items inside this nested Flex container. So let's check this out in the browser. So I'm on this page. I'm going to open up DevTools. I'm going to select the navigation bar. You can see that this is a Flex container. I'm going to expand the HTML. You can see we have a div on the left and a div on the right, our 2 Flex items. You can see this Flex item on the right is also a Flex container and contains these Flex items over here. So a navigation bar is a very common use case of using nested Flexbox. Looking at the next piece of guidance, nested Flexbox is also commonly used in sections and components. Looking at this page over here, the entire hero section would be a Flex container. The heading, paragraph text, and buttons are our Flex items. I'm going to zoom in on the buttons. This would now be a nested Flex container, and our 2 buttons would be the nested Flex items. So let's check this out in DevTools. You can see we have our Flex container here. If I expand it out, we have a div with our buttons, which is also a Flex container. So nesting Flex containers inside other Flex containers is very common. So let's wrap up by adding to our summary card, gap, nested Flexbox, and centering. In this chapter, we looked at nested Flexbox. We saw that we can have a Flex container with Flex items, and that we can convert Flex items into their own Flex containers, which is known as a nested Flex container. The nested Flex container has its own Flex items, which we can refer to as nested Flex items. So let's go and use nested Flexbox on our Quill homepage. If you recall, we're currently using Flexbox in 2 locations. We have a Flex container around our navigation bar, which currently has 2 Flex items, the logo on the left and the anchor tags on the right. And we're using the justify content space between value to create space between these 2 Flex items. We're now going to go add Flexbox onto the Flex item on the right. I'm going to zoom in on our anchor tags. This will now become a nested Flex container, which will contain the Flex items, the 2 anchor tags, which we can refer to as nested Flex items. So let's go code this up. So just a reminder of what our navbar currently looks like. The navbar over here is a Flexbox. And if we go look at the HTML markup, this Flex container has 2 Flex items. The logo on the left and the unordered list contains 2 list items, which are the 2 anchor tags. We're going to go convert this Flex item, so we'll end up with a nested Flex container. To do this, we need to go add a class, which I'm going to call nav button container. Back inside app.css, I'm going to select this class, nav button container. And let's go convert this into a flex container by changing the display property to flex. I'll refresh, and finally, we have our anchor tags next to each other. Now, because by default, we know that our main axis is running from left to right in row, we can add a small gap value to create space between our flex items, the anchor tags. I'm going to add a value of 2 rem. All right, so this navigation bar is looking a lot better. Now, something we did earlier on in the course was actually add temporarily quite a high height value onto the navigation bar. It's being controlled by this variable nav height. And if we scroll up, we can see that's currently set at 300 pixels. If I open up DevTools and select the nav container, you can see it's quite big. Now that we've aligned our buttons next to each other, we can go reduce the height of this. I'm going to go change this to 100 pixels. Now, this looks pretty bad. Let's open up DevTools and see what's going on. Because previously the height was 300 pixels, it was creating a lot of white space between the navigation bar and the hero section below it. Now, earlier on in the course, we actually had some margin bottom applied to our navigation bar to create some white space between it and the hero section. However, I'm not going to go add that on because in the next chapter, we're actually going to use Flexbox to center this entire hero section. So we're just going to have to live with this for a little bit longer. But this has been very successful. Our navigation bar is complete and looking really great. And you can see the power of using nested Flexbox. Now I'm going to scroll down the page. And the next location we're using Flexbox is on our footer over here, where at the moment our social media icons and anchor tags are being stacked vertically. So we're now going to be using nested Flexbox to correct this. Our entire footer is a flex container. We have the logo, the group social media icons, the grouped anchor tags, and the small text as flex items inside the flex container. I'm going to zoom in to the social media icons and anchor text. The anchor text is now going to become a flex container. And because this is inside another flex container, we can call it a nested flex container. Each anchor tag will be a flex item, so we can refer to these as nested flex items. And for the social media icons, and because this is inside the parent flex container, it too is a nested flex container. The flex items of this container are each social media icon, which again we can refer to as nested flex items. So let's go code this up. Okay, so I've scrolled down to the footer class where we're displaying Flexbox. Let's go look at the HTML markup. I'll scroll down to the footer. Here's that class. The footer semantic HTML element is the flex container, and the flex items inside this container are the logo, the social media icons, which live inside an unordered list, the anchor tags, which also live inside an unordered list, and the paragraph, which is the small text. So we're now going to convert this unordered list to become its own flex container, and this unordered list to also be its own flex container. To do this, we need to go add a class here. I'm going to call this social icons container. And for the anchor tags, I'm going to add a class and call it footer links container. All right, let's head to app.css. In the footer section of the CSS, underneath the footer class, I'm going to first go select the social icons container. We're going to set the display property to flex. I'll refresh. And you can see these icons now nicely appear next to each other in a row. As our main axis is running from left to right, we can use the gap property to create some space between our flex items. I'm going to set a gap value of 1.5 rem. Now for our anchor tags, we'll go and grab that container, which was footer links container. We're going to change this to a flex container by adding the display flex property. I'll refresh, and you can see our anchor tags now appear next to each other. And again, because the main axis is in row, we can use the gap property to create some space, which I'm going to just set as 1 rem. I'll refresh, and voila, our footer is now looking beautiful. And once again, this is a nested flex container. Opening up DevTools, I'll select the footer, which you can see is a flex container. I'll expand the footer. You can see the 4 different flex items, the anchor tag, the unordered list, and the paragraph. And for 2 of these flex items, the 2 unordered lists, we've converted those to become their own flex containers. The CSS course has been split into 2 parts because YouTube has recently enforced a 12-hour upload limit. So as much as I wanted the course to be in a single video, I've been forced to split it. Part 2 is available here, and I'd really appreciate it if you could please subscribe to the channel and drop a comment below about what you think of the course so far. I'll see you in part 2 where we'll keep the party going.